Welcome, everyone. So it's about time to start. It's my real pleasure to welcome you here. My name is Maria Gabriela Serra. I work in the strategy department of ESA, and I had the pleasure as well to put in place the first strategic risk management framework ESA is using. So I was the so-called agency risk coordinator of ESA for 8 years. Now I'm working on other topics, but still risk management is at my heart. And I wrote a paper as well this year for this conference on generative AI, the topic here, together with risk management to see if it could help us really identify risk, assess risk, mitigate risk. So I had really a great and vested interest in this panel. And it's my pleasure first to invite all our distinguished guests and speakers. So I'll start in alphabetical order. Professor Adam Ebdin from the Centrale Supélec Engineering School. Thank you, Professor, for joining us. You, round of applause. You are working in a research team in risk management, and you will tell us as well how you use generative AI in your team. Then I would like to welcome Mr. Massimo Comparini. Massimo, I don't know if we need to introduce you, everyone knows you, but so Managing Director at Leonardo. Congratulations for the new position, by the way, because you changed a month ago. So then in alphabetical order, if I'm not wrong, it should be Mr. Christopher Geiger, the Head of Audit and Enterprise Risk Management at Lockheed. So representing the other side, the industry on the other side of the Atlantic. Then we have, if I'm not mistaken, Mrs. Mariella Graziano in alphabetical order, 3 Gs, so I have to be careful to invite the right person. So Mariella, you are my hero, you know that. Mariella was in hospital 2 days ago, so she came specifically for this panel. Thank you so much. A big round of applause. And last but not least, Adam, who is the NASA's Council for Ethics. Thank you, Adam, for joining us, and you will give us also some very great insights on artificial intelligence and how we're going. Thank you. Thank you, everyone. So, 1, 2, yeah, it works well, perfect. So with no much ado, there's a timer here, so already 3 minutes for the introduction. So. But I'm sure you have many questions, so I would like you really to also be able to ask your questions in the public. I would like to address our young professor here. Adam, we know each other for quite long now, and you have been working on generative AI and on AI. And what is interesting is really to set the scene here first, to maybe have a definition, you as an academic, what do you understand by Gen AI in comparison to AI, generative AI? What's the difference? And maybe as well tell us, I heard, I heard personally, and I'm sure many people in the audience heard, that we say that generative AI is a stochastic parrot, that it's not intelligent. Maybe you can tell us a bit about that. What are your thoughts about that? Is it really a parrot or is it really intelligent? You probably have your views. And maybe last but not least, I know that you have your research team is also working on using Gen AI. Can you give us maybe some examples? Thank you. Many questions, but it will be passionating.
Thank you very much. Yeah, it's working. So thank you very much. First of all, yeah, indeed, we started to work on generative AI, using generative AI models a bit in our group. So I'm going to be speaking as a member of the research team. So also like displaying a bit what our research group at Centrale Supélec and the Université Paris-Saclay are doing. So we are the risk reliability and resilience team. We work on developing risk reliability and resilience frameworks and methods for complex systems engineering. And so the question that you asked me about the definition of AI, I think is a hard question because obviously like there's no easy way to define a set of tools, and probably each like people coming from different disciplines, they see it in different ways. However, I'm going to attempt maybe a try to give my understanding of AI and how we use it. So the artificial intelligence is the set of technologies that have been developed in the past decades that more and more mimicked what we usually associate to human intelligence capacities. So this is like the more generic definition about that. AI, like the development of these technologies throughout the years have been obviously exponential in the capacities of what these algorithms and these technologies can do. However, the recent advancement in Gen AI specifically, and this is what the separation between AI and, or like the set of definitions for defining what a generative AI model is, it's a subset of the AI technologies that is associated to creating new content. So generating new content that was not existing before. And this generative AI definition, or like the use of the term generative AI, was coined by Stanford, a team in Stanford, just to illustrate or to highlight this capacity to generate new content. I think everyone is familiar, of course, with the content generation of text, like ChatGPT and LLM models, but it is also used in other contexts to generate images, videos, translation, and so on. So these are the main differences. It's a subset of the AI technologies that have this ability to generate new content. And then, so on your question for stochastic parrot, I mean, I thought about this a lot. I mean, yes, because if you, like at the end of the day, all of these technologies are pretty much based on stochastic, you know, like some form of probabilistic models that try to, from a very large amount of data, try to predict the next set of data, or to regress these data to some information. So in this sense, yes. But in the general philosophical sense of, okay, what is intelligence? And is intelligence just the ability to use this information to create new content or to create new information? And in this sense, I do believe it's intelligence. So it's not just a stochastic parrot in the sense that it's repeating something that is useless based on information that is fed, because obviously these tools create content that is very useful to be used in industry, in academia, and everyday life even today.
Thank you very much. Maybe tell us a bit what your research team is doing on Gen AI.
Right. So I'm going to briefly to also leave the floor, but briefly say like our
in relationship with risk, of course,
exactly.
And how you identify risk.
Our research team in reliability. So we do have a professor and a few PhD students who are trying to look at the LLM models. So the foundation models that exist today, are they good enough to be used in the context of reliability engineering? Right. So for example, we expect that people will be using like LLM models for all sorts of applications. Can you say maybe? Yeah, so large language models, indeed. So large language models is the most known form of generative AI models that everyone is currently probably using in any case, like ChatGPT, right? So this is one of the very well-known large generative models. And LLMs is being used today in everyday tasks, right? Like you want to write, I don't know, your resume, you want to do something, like everyday tasks is being used. And we suspect that people will use them as well in their jobs, right? So for example, someone wants to write a risk report or want to do a reliability analysis on something, will probably also go to these tools and use them to support the functions that they're doing, which is fair enough, and that's very good. So the team in our university, what it's trying to do is trying to see, using these models, what do you get really something that is trustworthy and reliable for reliability engineering? So we do have a lot of expertise in reliability engineering, and we have a lot of expertise in risk analysis. So we know, like we have expert systems. The people who maybe in the room work in these domains know that we have, like usually you use expert system based on expert knowledge about the specific component or the specific task that you're trying to do. And we compare the output of these LLM models to these expert systems. And I'm just going to leave it here, a cliffhanger. The reality is that today, these systems are not actually good enough for reliability and risk assessment. That doesn't mean it cannot be good someday, but at the moment, they're not really suitable for these tasks.
Maybe that's a message of hope that we're still going to have some job in the future if it's not reliable enough still. But you said something about trustworthy results. And I'm going to address you now, Christopher. about you at Lockheed Martin, because you told me that you're using generative AI in your enterprise risk management team. You're heading as well the enterprise risk management team. And I would like you maybe to tell me how you use AR and generative AI, both of them, why not, to generate risk scenarios, okay, to a bit foresight and so on for your project. And maybe you could give us some really tangible examples on sustainability, because it's the theme of this symposium here this year, sustainable space. So maybe you could give us some examples on that.
Yes, of course. So first, I'll get to the sustainability part. I know that's right in the meat of the title here for today's presentation. So Lockheed Martin has actually been using AI before generative AI for sustainability, and then when the LLMs kind of jumped onto the market, them as well. So I'll give you two examples. We have a partnership with NVIDIA to do a digital twin of the Earth weather. So for NOAA, the U.S. National Weather basically organization, and basically this digital twin uses AI and enormous amounts of data. So sea level or sea level information, but also sea temperature. So a lot of space-based temperature data and lots of other data that goes into it to actually help inform weather prediction. And this actually came out of our risk management work, because we have 150 sites around the planet, right? We're doing materiality assessments for sustainability, and we also look inward to see what data can we use ourselves to actually mitigate our own risks to do with whether it's climate change or other issues. Another example that came out of that is when we did look at all those facilities, we said, of course there's climate change, sea level rise risk, but as the climate changes, there's also different fire risks, right, or water scarcity. And fire in particular is something that came up on our register as interesting. We had to look back at ourselves and say, well, we have firefighting helicopters, we have firefighting aircraft, we do artificial intelligence for tactical scenarios. Why couldn't we do AI tactical scenarios for fire? Why couldn't we help people deal with remote wildfires and predict them using all the data that we have? So we're actually now in the business of firefighting intelligence as a service. Because a lot of organizations, firefighting organizations, are not, flush with money, but they do need the information to pre-position assets and actually try to predict where a fire is going to go to save lives, save property. So this is actually something that came out of our sustainability group to help our own risk management that actually became a product. So those are kind of two examples related to sustainability. I'll also mention in our enterprise risk management group, we use the LLMs, the generative AI, to read all of the comments across the company. So if you imagine you have a small risk management group and nobody can read all of the risk statements and the programs. You have thousands of programs in our company or all of the assessments for new business. The individual executives, right? They all go read all of those, but no one can read all of them. Well, of course, generative AI can. And so we're actually able to tease out emerging risks in the company by reading unstructured data, right? AI was always good, like those weather examples, with structured data. You have numbers. But this generative AI can create intelligence, at least for a human to convert to intelligence, from all this unstructured data, to read it, to do sentiment analysis, and then to bubble things up. Now, to Adam's point, we don't just take that raw data and run to the board of directors either. So we have some smart humans look at that and tease out things. But I can tell you that it has, in some cases, brought things to light before management was aware of them.
So you did find the results trustworthy. So that there was can you give a rough percentage of how much would you find? I mean.
And the thing is, if you just ask a raw LLM that's been trained from the entire internet, right, then you're often going to get hallucinations. You're not going to know where the answer came from. There's no reference to it. So we instead have our own internal LLM developed just in our company, and we have a RAG, an RAG, that actually just has our data in it. You attach to it. I think of it as a short-term memory for AI. And the AI, if you use its foundational model, it can't tell you where it got the information from as it generates predictive text. text. But if you put it in the RAG, and it's essentially short-term memory, it can reference it. And so as it talks to my auditors or risk managers, it tells them not only, yes, this is a risk in this type of the business, but it actually has a reference, a footnote. They can click on it, and it goes exactly to that document of the millions of documents that it's input and says, this is where I got this information. So we actually don't find it hallucinates on that data.
It is identifying risks, and there is a human, a risk manager behind, who just checks upon what he has identified. So that's very interesting, because in the study we did with a colleague from Aerospace Corporation and NASA, indeed, I was mentioning at the beginning, and we wrote an article on that, the weakest part of Gen AI was in the risk identification. But this having been said, you talked about your own chatbot, and we had only public information. It was on the Artemis program, and identifying risk on Artemis program. And of course, I mean, we could not use confidential information. We took only publicly published information. And this is very interesting, because when you are using your own LLM, then this makes really the difference. And you, Mariella, I come to you now. You told me you were using your own chatbot, indeed, at GMV. And maybe you could tell us as well a bit, you know, because you use it at different level. You use it in management, but also on products design. So it's quite risky, huh? Risky to use it on products design. But maybe you can give us also some examples and how you're using your own chatbot, as a matter of fact, to identify risk or assess risks or even mitigate risk.
So thank you very much for the invitation to look at Martin, and for also the patience with me. Yes, indeed, we are using, I mean, GNV is a company that just made 14 years. So
your microphone close.
Oh, sorry. We can rely on lots of data, lots of experience, which is one of the topic of the Gen AI, having reliable data and then secure them. So we are using AI in general. In project, we are using AI in product, and we are using now we have some pilots within some pilot project within the company to see how we can take advantage and make our, let's say, daily life better. Because for me, I mean, I'm an hooligan of natural intelligence, so I see artificial intelligence something to make better life, not really to put aside the natural intelligence. So. One of the problem that, as I was mentioning, we have also a company that works in AI, also associating with cybersecurity, because as I was mentioning before, in whatever the tech, okay, depends on the technique you are using, but you have always the problem of data. You have always the problem of having reliable data, or the data that really are useful for what you want to do, and then there is a problem of security. Because especially if you have your own chatbot, I mean, you want to, which we do, we want to protect our data, so we are injecting all our experience there and trying to come out with interesting elements. So what we are using, depending on, you know, that GNV is working in many different areas, maybe too many sometimes. So in the area of, let's say, more technical aspect like GNC, robotics, space traffic management, we are using there, and we are not using generative AI, we are using other technique, deep learning, CNN, LSTM, so other techniques that let's say, because we need to for instance, recognize object within our images for our navigation systems. So it's a different story there. But we do have a problem there for the data, because there are not so many data in a real space system, which is one of the problems. So ESA and many of our clients are opening lots of ITT saying AI for GNC, AI for operation, AI for... This is always a problem, because AI is a word. I mean, first is, what do you mean with AI? Then going to the generative AI, I was mentioning that we have different pilot within within the company at the moment, taking advantage, working with our own chatbot. So and we have identified specific problem that a company normally has. One is, for instance, the knowledge management. This is something very important. So we have a project that now is called like GNV Knowledge Finder. And the goal of this is really to identify within the, I mean, you know, we are still a family company, but we started as a new space company from a university of 2 people, and now after 40 years we are at 3,500, so different story. And knowing within the company to whom you might talk, or where the right information are, or what is giving a solution to your problem is something very important. So we have a pilot there where we are putting all the information, centralized information for the company's employee. So they can make very easy question, who's handling this technology, to whom shall I talk for this specific problem?
That's fantastic, no? Because I mean, we've all dreamt of having that in any company, you know, a knowledge management tool telling us who is the expert in this area. And specifically, I mean, at ESA, we worked a lot in blocks of projects like Rosetta, Mars Express, Venus Express, blocks of projects. So of course, having lessons learned. So I suppose you use it on your lessons learned as well.
Yes, but because what we did is to do, I mean, as engineers, to make, okay, which one are our problems? My problem is knowledge management, my problem is organization, my problem, for instance, is making a good proposal. So we have another project, it's called AI-driven proposal generation, GenAI proposals, frankly, basically. So what we do there also is injecting lots of information on proposals, and then this, I mean, because there are some proposals that need a little bit more work, but there are a little bit more standard. So we are having a pilot for generating a proposal, good proposal in a more efficient way. Of course, then you have to work on them.
Gaining a lot of time then,
yes.
huh? Thanks to Gen AI, as a matter of fact. It's a bit what Chris was saying. So you gain so much time if you can inject all these reports, and then it makes a synthesis of all of that. Well, you gain a lot of time. Indeed. Thank you, Mariella. Now, I mean, I think first, I want to thank Massimo, because you were at Thales Alenia Spazio, and it was the only company who really replied very thoroughly to the survey we sent them for the paper I was writing. So Maria Antonietta was very proactive on that. And again, as I said, we identified we asked ChatGPT-4, please identify the top 20 risks on the Artemis program, okay? And then we realized that, okay, the result was not so good. So we trained the tool by injecting documents we found on the net, NASA reports, et cetera, and then we re-asked the same question, please give us the top 20 risks. It was a bit better, of course, but it will never be as good as if we were able to access the chatbot of NASA with also, of course, confidential document. But you were using ChatGPT-4, so of course we had no way of accessing that. But this having been said, on mitigation plans, ChatGPT-4 scored quite high, above average. So people like Maria Antonietta, other people said, wow, that ChatGPT-4 is giving us good mitigation actions to solve risks on Artemis program. So we were quite surprised. What do you think, Massimo? I mean, how are you using yourself within Leonardo, but also you can talk about your experience at Thales Alenia Spazio. How are you using generative AI and AI in general? I mean, we can talk about both, of course, to help you identify and maybe mitigate your risks. So giving you some ideas of solving your issues on programs.
Thank you, Maria Gabriela. I think it's an extremely interesting topic also because we have different angles to see what we are discussing. Of course, one angle is what Chris described in terms of processes, in terms of knowledge, and by the way, also Maria, in terms of organization knowledge and all of that, which is extremely important due to the complexity of the mission that we need to address, like Artemis, and also we have many examples at the European Space Agency level. Let me take the angle of how to mitigate risk for so complex space mission from an engineering standpoint. What I mean is that, okay, you refer to Artemis. We know the complexity of all the missions and all the vision on the Artemis program. Okay, we go around the stands, around the booth, and we see pieces of hardware, pressurized model, rover, automatic machines. Myself, I always made this example. I don't know how many astronauts we will have on the surface of the planet 10 years from now. Let's say 10 or 15, a number. I'm sure that for each of those astronauts, we will have maybe 10 or 15 machines helping him and her to make their job. And of course, I cannot imagine that women and men on the moon, they will have 10 or 15 different joysticks and control those machines, like our TVs. You know, we have so many telecom. Why I say that? Because of course, we will have those machines that are progressively more, let me say, more intelligent, AI power. I don't know, Gen AI power. This is another topic that maybe we can touch in the second round, because, you know, Adam gave a kind of, let's say, definition about AI, Gen AI. But then, of course, when we will really injecting Gen AI inside our systems, we need to understand what is the target and how we, I know it's difficult to say, but how we can control that in any case, if a Gen AI powered machine is on the moon, what is the control that is doing the right things to protect the life of the people that we are there. So I said that because imagine how we are using AI, and then let's talk about Gen AI. First of all, we need to understand what is the target of all those machines cooperating with the man, which is extremely important also to study in terms of philosophy, how the man will address the challenge first. And second, imagine the amount of data that these man-machine cooperation system will generate, and how at that point Gen AI may help to manage the risk ex ante, as you described, but ex post. I mean, after that a mission is in operation. And I'm convinced that very soon we will be in a situation where the astronauts could not have the time to call back to the Earth and to say, Houston, we have a problem. Or I'm used to say, Turin, we have a problem. And they need to take a critical decision there, relying on AI and Gen AI. So this is just to say that to the question, how are you using AI and Gen AI, it's a bit more complex looking to the missions that we are targeting first. Second, and I highlight on the sustainability, Chris gave an angle. Of course, at European level, we have Destiny, Destiny Earth, so I mean the digital twin of the Earth, and again, and we are using AI to have those prediction models from huge amount of data that generate with our sensors. Just an example, Copernicus program is one very rich database for all of that. But let me stay still for a moment on the moon, just imagine that. So how to make sustainable those missions? You mentioned about Artemis program. It's not just to go there, it's how to make sustainable over the life cycle of the missions that we have. And I really believe that AI is and will be a fundamental tool. Maybe in a second round, let's talk a little bit more on Gen AI. Also with respect to a view that we have as a group, you mentioned as Leonardo as a group, where the convergence between the digital technologies, high power computing, not necessarily on Earth, but also in space and on the surface of the planet. Artificial intelligence, cloud in space, all of that are infrastructure that will be AI power. So we are working a lot on this, and the work is on the specific technologies, but also having in mind all the life cycle and the sustainability of those amazing missions. It's not just to launch a single satellite.
Talking about sustainability, I suppose you are also working on collision avoidance and space traffic management processes using, of course, AI, because the goal would be indeed to be able to use AI, and probably already starting doing it, to minimize the use of human being to deorbit or whatever if there's a collision happening.
Okay, we know, I mean, the motto of this year of the IAC is responsible space for sustainability. So we know what is going on in the low Earth orbit is going to be more congested and more populated. And of course, if we follow the exponential growth of debris and objects, no way. I mean, it's AI. It's a fundamental tool that today already is part of the space domain awareness of command and control to give right information, to give alert on possible collisions. And okay, we know SDA, space traffic management, and space surveillance. It's fundamental to have a sustainable space. And I think, okay, Mariella mentioned what they are doing. I mean, everyone in Telespazio, that of course we have ground operations and ground systems. We have a huge amount of AI that already today help to take decision and to give alerts. So.
Thank you so much. So I'm going to go now to you, Adam Greenstone. So you, as the NASA's Agency Council for Ethics, because we talk a lot about generative AI, but how about the way we use it? And you're interested in that personally. I mean, that's in your role. Can you give us your thoughts on what you just heard now from the panel, and maybe tell us as well if we should in the future regulate more, because now everyone is doing what they want in AI. Should there be some regulation? You know that in Europe we had one, the AI Act in July coming out. What are your thoughts?
Thank you, Maria Gabriela. An honor to be here. I am not an AI expert. We have at NASA a chief AI officer. We have lawyers that work with AI far more frequently than I do. So why is Greenstone here? I have a perspective, and that is, as the Agency Council for Ethics, I have a perspective on the relationship between ethics and sustainable space exploration. The big picture, that's a key part of this conference. How do we get to sustainable space exploration? And it's my contention that ethics is part of it. Now, I'm going to tell you what my takeaway is, and then I'll get a little into what we're doing at NASA. A pitch that I have today is the importance of self-regulation in doing AI. As Maria Gabriela mentioned, yes, there's a new European law, the AI Act. The Office of Science and Technology Policy and the U.S. Executive Office of the President is a blueprint on AI principles. At NASA, we have an AI framework. Of course, government regulation is coming, but my point is not to wait for it. And I think that's one of my takeaways in the presentations here. They're not waiting. They're not waiting for regulation to do AI the right way. I'm going to come back to this sustainable space exploration theme. Let me tell you a little bit about what's going on at NASA with AI. Now, first of all, what I would encourage you to do to learn, just do a web search, AI and NASA. We have a robust web page on some key AI activities. Here are some examples. Optical navigation. Systems that when an astronaut or a robotic spacecraft is on another celestial body, take a single picture of the horizon, a system that will be able to use the mapping data to be able to determine where that astronaut or spacecraft is with the same precision as the GPS system as if they had one, but they won't on that celestial body. A next step is virtual worlds, a system that will generate data representing a virtual world that can be used in planetary landing. As the spacecraft comes down, what are the dynamics of what it's going to face using the limited information that is available about that celestial body to determine what are the characteristics of that virtual world. The Mars, let me get this right, the Mars Organic Molecule Analyzer, MOMA, that's going to be on the 2028 ESA-led mission to Mars. Machine learning that will enable guidance to the mission team on, all right, you've drilled for a sample, what should we apply to that sample? What experiments in a world of limited capacity to get the most scientific value? And then when to drill next, recommendations to the mission managers. That's a step towards autonomous robotic spacecraft that will generate their own data and then apply that data to make their own decisions on a solar system mission autonomously. That's an example of what we're doing. Now, how does ethics and sustainable space exploration plug into this? So let's step back. A very important aspect of space is its signaling value. And this isn't just speculation. I mean, there's scholarship in this showing through history and economic analysis that for a few centuries now, countries and companies and individuals and other organizations have made investments in space and used them to signaling about national values, individual aspirations and priorities, corporate strategies. There's a corollary of this, that because space gets great airtime in humanity's attention, and a reputationally adverse event in space will be heard with a far greater amplitude than a similar event in other industries and sectors. This is where we step back and say, as I think our deputy administrator mentioned earlier in the conference, the importance of applying the communal knowledge of humanity. We work together to build the space exploration enterprises of the future. Governments, industrial partners, scientific organizations, academia, and others. A reputationally adverse mistake by any of those entities can set the entire communal enterprise of space exploration back. Now, here's where I get to regulation. It's going to take, in my view, many years for governments to get their arms around what is effective and useful regulation of AI. We see the same thing going on in crypto. What that means for the moment is that it's vital for space actors to make these wise decisions themselves. What is the responsible way to deploy and use AI? You know, we've seen in the history of space exploration many examples where private actors have made their own decisions, not mandated by government requirements, to do the right thing, to avoid adverse events that set the communal effort towards space exploration back. And I think that's my key message and takeaway, that during this period, while we're waiting, the importance of self-regulation to help our communal effort.
Thank you, dear Ed. I'm just having some thoughts on the fact that, okay, you say we should auto-regulate, so every person should be, like, let's say, responsible. I might have some doubts on some of your, let's say, private actors, and one of the biggest private actor on regulation. It might be a bit tricky to leave it to people to decide on their own. I don't know if for example, Elon Musk, I'm thinking of now, knowing how he likes regulation, would be really open to regulate himself. What do you think? I mean, in that case, I mean, in cases where people would be a bit reluctant to regulate.
There is an analogy from the financial industry in here. You know, if you look at financial risk management in banks and financial institutions, for example. There is a concept of, when you talk about capital, appropriate levels of capital that a financial institution owns, there's going to be something called regulatory capital, where the regulator will say, based on your characteristics, you have to have so much of a proportion of your assets in capital. But there's also a concept of economic capital. And this is accepted, as normal in financial risk management, where the institution makes its own decision in terms of, all right, this is what we need to do to satisfy the regulators, and we'll do that. But in order to satisfy our own organizational requirements, the requirements of our members, our account holders, to keep our assets safe, this is what we have to do. And it's very normal for that to be at a different level. So I think when you put it in that context, the regulation is not necessarily the big burden. It's the burden of what the organization says itself is right.
So not seeing it as a restrictive part, but as a positive part to enable you to economically grow as well. Well, okay, that's a kind of positive statement. Actually, we still have a bit less than 20 minutes. Shall we maybe give the floor to the audience if there are some questions? I see some questions here. Maybe the lady in the front was the first one raising hand. Please here.
Hi, good morning. I'm Cheyenne, and I'm a PhD researcher, and I specialize in explainable AI. So I would like to ask you just two short questions. What do you think XAI, explainable AI, can add the most value as more AI applications are used for space missions? And the second question is, as we explore the emerging capabilities of Gen AI, what other AI concepts such as AGI, artificial general intelligence, are being considered for investigation and experimentation?
Does anyone want to?
I can jump in on that first one.
Okay.
So for the explainability, so Lockheed Martin has our own principles. As you mentioned, there's a lot of different rules on system engineering using AI across all of our products, including space, and one of them is explainability. And I think one of the aspects, and you're the expert in it, that this is going to be more and more important is as we have systems of AIs, right? So in one AI, the idea that it's a black box and add explainability and maybe auditability is good, but we're going to move into a place very soon where there's a lot of AIs talking together and working in a very complex system of AIs. And in that case, I think it's very key to be able to either have a state machine, or however you want to look at it, of the explainability of each module. You can think about living systems this way too, kind of in organs and whatnot. So I think for us, explainability needs to be at that model level, and then we bring it up a level to the system, but it's got to be at the lower level.
I think that first, that will be valuable to extract information from a huge amount of data that we will generate. And it's the only way to have really a support, to have the right interpretation of this, first. And second, just following what Chris said, as soon as we will move to more sophisticated, which means to have agents that will work, we need to have a kind of model to understand what each agent is doing in its environment. And I think that looking to what Adam said, I think this is really a challenge, for instance, to have a sustainability planet exploration like on the moon. And I take just a few seconds to give a comment to what Adam said, because I fully agree that self-regulation will be fundamental. I mean, the technology is going so fast that, of course, we need the regulations. But the regulation will never prevent what technology can do. And I think, and this is extremely important from an engineering standpoint, I think that we need to have more and more piece of the organization looking to the ethics and maybe also philosophy working with the engineers, because self-regulation will be fundamental.
Yeah, if I may add something, I mean, space missions are very complex, are system of system of system of systems. So it's something very complex, and all those systems, they have different requirements, different needs, different elements. So we see very important, for instance, one case, how you handle the operation of a space mission. This is something very, very, very tricky. You know? We have one of the projects that we are running currently is really related to make operation efficient. And you have there different problems like enhanced interaction. No? How you can improve your interaction with those diverse systems that have different requirements, different way, and different needs. Efficient data management within all those systems. You really need to see, depending on the different elements, how and those different elements sometimes, in case of AI, are different databases. So you have really to see how you are managing all those elements. Rapid response time, Massimo was mentioning. There are situations in space where, I mean, you need to be quick, otherwise you are dead. Production ready system. So you have to really try to ensure that those systems are ready for deployment when they are due. So there are many elements. Also, a rapid and advanced capability of search the data that you effectively need. So and within all those topics, you will have maybe different solution and different way of handling. We have in space mission, being the complexity we are handling, we normally shall have a big amount of data. Sometimes in space we miss data, which is a problem. But if we want really, we are advancing in exploration and in all those things, the amount of data will be higher and higher, no? And then for helping the astronaut, for taking right decision, for deciding to go here or the other way without killing yourself, I mean, you will have to handle different problematic at the same time. No? So security, rapid responsiveness, many things are needed.
Thank you. A word from the academic side?
I just want to maybe address, take a shot at the second question, where you answer, like asking mainly what should be the next, like things to look for, like to developments, the interesting things. You mentioned AGI. I'm not really going to treat the AGI question, but I think one of the things that we haven't talked about yet is that all of these models come at a high computational cost. And if we're here talking about sustainable, like the sustainability in space, we tend to forget the amount of resources used to generate these models and to use them. So I think one of the most important things for research to focus on is, I mean, from a pure technical point of view, because I'm interested in advancing the AI world, and I think one of the most important things is to work on frugal models, like highly computationally efficient models, improve the processes. I don't think explainable AI, adding a layer to explainability is actually going to reduce the computational complexity. It will increase it. And I think maybe which is very important, right? So explainable AI is one of the most important things that we should be working on. But I think also we should be working on developing more efficient algorithms and computational systems.
Thank you for this Thank you for this very different insights we had, but I have the feeling that big data is the word now, and the management of these data is going to be quite a challenge in the future in our AI, and the infrastructure we will have behind this managing big data will be also something we have to consider for sustainability. Another question maybe? Yes, please, here. And then we'll have to go there as well, on the other side as well.
Hi, thank you. I wanted to follow up on my friend's question here. I'm also a PhD candidate studying generative AI and explainable AI for space missions at Purdue in the US. And I wanted to ask you about a key limitation or a challenge that we have nowadays, which is something that you guys mentioned. The elephant in the room is data availability. So when it comes to space missions, especially space missions to cislunar space, for example, we don't really have enough data available, and even the data that we do have is usually restricted to companies. So when it comes to that issue, what are your insights on how to circumvent this issue and be able to generate data, be able to use generative models despite having this key challenge? Thank you.
Who wants to go first?
It's very tricky because, as you mentioned, data are the basis of companies, so and they are protected. I mean, and it's true every time for instance, sometimes we work, a company like mine, we work at subsystem level, and sometimes we miss system level data and we cannot get them because they are restricted, and it's very, and even sometimes they are restricted within ESA themselves, so data are a problem. Now, the question here is, we are talking a lot about space economy, ecosystem, so I think if we really want those things to happen, apart from the self-regulation, we shall also put in place, I don't know why, I don't have an answer, mechanism for sharing data, because we are all suffering of missing data, and there will not, I mean, maybe one day there will be 300 missions every day, I don't know. If there will be only one mission every 5 years, the data are from that mission, so.
Yeah.
In the States, yeah.
Yeah, well, and of course, I'm sure you're well aware, but a lot of groups have had to move to synthetic data, right? So you only have so much data. You're not going to get more except for at great cost. And one benefit of synthetic data, like you think of self-driving cars, is you can also speed it up. So you don't have to do it at real time, right? You can generate, faster than real time data. Now you can't always trust it, but if it's all you have, you can simulate on it, work on it, and then as you do get little bits of real data, you can check that against your models and then update your simulated data. So I think we have to be thinking about that. That's how self-driving cars, you millions of miles, but billions of simulated miles. There's rarely a giraffe crosses the street, but you want to try that out, right? So you put a giraffe across the street and make sure the car stops. And the same thing with with space-related data as well, I think.
I think that Adam gave an example of how from a single shot taken far from the Earth, you can establish, let's say, positioning with high precision. So I think that if we believe that Gen AI will contribute to all of that, synthetic data will be fundamental, and we will learn mission after mission how to refine a model between real data and synthetic data.
I'll just say, this seems to be, to me, one of these areas when one is reviewing a system that you get to the question of, is it scientifically and technically robust? Do you have everything lined up so that simulated data makes sense? Or is it too far away that you might be getting into trouble?
I just want to comment on this because I think it's very interesting what Christopher mentioned here. Actually, I'm supervising a PhD student who working on developing scenario generation models for autonomous vehicles, and the aim is to train the autonomous vehicle to learn how to drive, self-drive. And we focus on the reliability and risk aspect of it. So indeed, we want to generate the scenario as the giraffe, which is very hard because it happens, like if you really want to take the data set, like actually you don't have data about that, right? You don't have data about every possible scenario that can happen, and it doesn't exist simply. But you want to generate it because you want to train your models on like all the possible scenarios that might happen, right? And to that point, what we do, and also like maybe it's kind of something also that Mariella touched upon, is that what we do is that we're using generative AI models to create ontologies, like knowledge management systems, through which we can actually generate scenarios that maybe haven't occurred before even in the data set. And I think this direction, like we're trying to use it now for the autonomous vehicle, but I think this direction should be really explored in space research as well.
Thank you very much. It was quite an interesting question. In training the tool and getting better scenarios, this was also something we discovered as well while doing our little trial on Artemis. So maybe we could take 2 questions in a row then here in this area, and then you can choose what you want to answer, because we are a bit, we still have 7 minutes left, and I don't want people to be frustrated if they cannot ask their question. So there was someone close to you as well. Maybe you could give him the mic afterwards.
Andrea Sportillo from Onera, PhD student as well. My question is related to human error in annotations, because most of the applications still today use training as an example based on human annotations. So from a general point of view, does this error propagate through the models that we use today? And is it a risk that need to be managed? And how we can characterize these errors propagation eventually?
Question here. There was another person here who wanted a question. I saw 2 hands rising, or so nobody on this side. Okay, so maybe we can it's fine. So you can answer if you wish the question.
So maybe I can try to answer to what I understood the question. So it's the errors in the models and how they propagate throughout the training and like how they impact the risks at the end, right?
Errors in the annotations. So
okay, got
human create the labels, and then there are some errors in that.
Gotcha. Well, obviously, if you have errors, like you know, like if you have bad quality data, you get bad quality output, right? So that's an obvious statement. But I want to maybe come back to something Christopher said earlier on, and what I mentioned in the beginning when I said in our research when we discovered that using the LLM models, the foundation models, and just use them as they are to just generate reliability metrics for some components failures for robotics and stuff like that, we realized that they actually produce unreliable results. And then Christopher mentioned that what they do is they fine-tune these models, right? So they fine-tune these models using their own expert systems and data that they have, right? So this is what we call like creating your expert agent within these models. Like you take the foundation model, the LLM model, and then you start fine-tuning it with the expertise that you are looking for. For example, I know for a fact that there are now companies that are doing this for legal. So LLM models that are just experts in legal, and they can produce legal documents, and they train them on legal documents and so on. I'm yet to know if it happens in risk and reliability world, but maybe probably it exists somewhere. And what you do here is you keep fine-tuning your models, right? So you keep improving by giving it, like getting feedback. I mean, this is the process, right? Getting the models and seeing that they're not really giving you the results that you expected, and then you keep fine-tuning them towards your specific goals. So yeah, error is inevitable. If you have errors, that you're gonna get you know, like a not so good result out from the other side, but you constantly try to work on that. Yeah.
Chris, you had some thoughts on that as well?
I think that covered it, yeah.
Okay, fantastic. We still have 4 minutes left, and I had a question to you all, basically. The other day, I was listening at the radio, and they were saying that, I think it was researchers in the US in Harvard school, business school, which a researcher was trying with his team of researchers to set a clock to say on which date AI in general, not generative AI, but AI in general, will take over human intelligence. So, you know, you probably have heard about the apocalyptic clock, the last day of this universe, but this is another type of clock, and kind of pessimistic one, you know. It rings a bell. I suppose some of you have seen the film Terminator. So it made me a bit wondering, are you positive or are you fearing AI in the next decades? And maybe one word of each one of you. And if you were the king or queen of a day, what would you like AI to be doing in the next decades? Maybe we start with you, Professor.
So thank you. So the first question is on what is the day that this will take over? Well, I don't look at it like that. I think today's capacity in some of the models have far surpassed what any human can do anyway. Not in all the tasks, but in specific tasks. Like we have models today that can do things that I don't know any single human who can do them. So I think it's going to be kind of complementary. Our job is probably to find how we can work with the tools that we have created, as we all have always done, right? And not to fear that they're the replacement. Like this is not my position about, like, it's my philosophy that it's going to be replacing. It's going to be complementary. So we're going to be using these tools to advance ourselves as we have always done. And
the second question on
because
you're a bit tight on time.
Yeah, so I'm gonna go very fast. I think what I would have loved, or like what I hope will happen, is that these capacities will allow us to have more reliability, better risk management. We prevent disasters and challenges that have happened before because we were not able to communicate well between the teams and so on, and now, or like identify the right reasons and so on. And I hope that this will see great reduction in in disasters, that have human impact.
Helping disasters management. Thank you so much. Massimo.
Of course, it's very hard to respond. I mean, I really think that one of the critical points is that the debate on the scientific community is the discontinuity moment when an AI, Gen AI, may work and will have the computational power to work on itself. And this is, of course, something that will mark. But I think that we will discover just on the way. And I link what Adam said. I don't think that there is artificial intelligence and other intelligence. I mean, it's a complementarity, and we need to work. We don't have just a single intelligence. We need to work with the human intelligence together with the AI as an opportunity to understand really well.
To progress humanity, maybe.
Yes, we
at
cannot
the end,
ask
at the
for
service
now.
of humanity.
Now. And again,
Okay.
I think the ethics will be really extremely important for the self-regulation that you mentioned. Without that, no way, we cannot respond.
Thank you, Massimo. Christopher, we're a bit running out of time, so
No, very quickly, I
quick
would
thoughts.
say that I think we should be positive on how AI is moving. If you think about electricity or computers, none of these technologies actually reduce the number of jobs, right? It actually increased the number of jobs for humans and the creativity that we're able to apply to the world. And on the second, I think that how that applies is really medicine. So human medicine, right now we have, our healthcare, I suspect will be considered rudimentary compared to in just a few decades. Because what AI does well is use enormous amounts of data and customize it to people, right? And right now we have a medical system that isn't customized to each person, and that could be the revolution that really
It is already revolutionizing in the medical area. Indeed, in epidemics, for example, it's helping so much. Mariella, what are your thoughts?
I'm going to be very politically incorrect because I fear more stupidity than artificial intelligence. I'm sorry. But what I think shall we do? There is, together with those things, there is a clear change of also within the education, because we cannot have those techniques which shall be for the benefit of human being, in my opinion. Together we're losing the capability of critical analysis. So I think there shall be also a mechanism that, in my opinion, is not happening in having the, I mean, the brain is one of the, our body, human being, we are unique, so I think we need to preserve this and using all we are doing in our benefit, not in controversy.
Yeah, thank you. The uniqueness of human being. Adam, what are your thoughts?
I just took a picture of the audience. I went to a Ringo Starr concert, and he did that at the end to thank the audience, and we really thank you for coming. And my thought is, I think that it's going to be like a J-curve, where there's going to, any new technology, there's going to be some noise at the beginning, expectations not met, a little bit of confusion, but then at some point, it will take off, and it will ultimately come ubiquitous. And I think with regard to self-regulation, I would say that the quality of the eventual regulation will be very favorably influenced by the high quality of self-regulation, if that's achieved. I think that's an important objective. And if, in terms of what I can see for, future uses, this might be a little modest. I think, Anna Maria thought if you were king or queen for a day, this is more of, baronet or an earl. I would just be happy if we had systems. It used to be legal opinions were very formal, and now we just do all these emails. It's very hard to record them. If we had automated AI that could reliably preserve those records, so that knowledge could be used effectively going forward, I think that would be very helpful in the legal and other professions.
So many messages of hope. Thank you so much to my distinguished panelists. A round of applause for them. Thank you.
welcome to you. Thank you so much for coming to our session this morning. We're calling it, how can we pioneer what we call a circular economy in space? It's about some really fascinating technologies. We're going to be talking about in-space servicing, manufacturing, those kinds of technologies. And if you're interested in how you can turn space debris into propellant, then you're in the right place. If you want to ask a question, we have, let me just click for you, a QR code. We're using Slido today. And you can scan this. You can pop a question into your phone. Hopefully, I'll be able to see it on the iPad. And secondly, let me just quickly introduce myself. My name is Katie Haswell. I'm a journalist, a broadcast journalist, previously for BBC, ITV in the UK. But I also have the good fortune to host the live broadcast during rocket launches from the Guyana Space Center in South America. So I'm very lucky. I've seen lots and lots of launches over the years. Right, before we get into the nitty-gritty of what the circular economy actually is, let's just get a little bit of context. You don't need me to tell you that space is booming. And from our voracious appetite for high-speed broadband to our plans for colonies on the moon, habitats on the moon, and beyond, the sector is quite literally teeming with opportunities, and it's expanding exponentially. But there's a problem. The size of space, as we know, is rather large. But the orbits, the usable orbits around our planet are filling up. They're getting quite crowded, actually. And as we know, space debris is a problem. It's escalating. And resources, of course, on the moon are finite, so we can't just go and use those ad infinitum. So what are we going to do about this? Well, the circular economy is one of the answers. Because if we want to keep that giant working zone in the skies above us open for everybody to use, then we really urgently need to rethink our strategies. So this is very, very important. There are three main regions which space interacts with, and we need to really treat each one of these differently. Obviously, Earth. We need to think very carefully about how we can reduce the environmental impacts of space on our planet, and that, of course, includes climate change, biodiversity, and loss and pollution. Space, of course, affects Earth's orbit, inevitably, so we need to manage and reduce space debris, and we need to be responsible in our satellite operations, and of course we need to avoid collisions, which is a big problem. And the moon and beyond, we need to really be responsible when we think of the moon as a museum, preserving our ancient universe, and prevent contamination and manage waste. The circular economy, actually, a good way to think about the circular economy, which it really is an answer to many of these challenges, is to start by thinking about a linear economy. So most industrial processes start from the beginning, go to the end. You start with your raw materials, you design a product, you produce it, you launch it, you use it, and then at the end of its life, you throw it away and it becomes waste. Whereas with the circular economy, we're circularizing the materials and the products that we've got. So, for example, if you look at this grey line at the top, we can, instead of disposing of raw materials, we can use them again as raw materials, rather, disposing of an old thing, using it as raw materials, or we can refurbish, we can repurpose, we can reuse, and of course, all of this is about maintaining what we've already got and life extension. I mean, if you think about it, you know, we talk about electric vehicles, but at the end of the day, the most efficient and sustainable car you've got is actually the one you own. So I would like to introduce our fantastic panel and bring them up onto the stage. Ladies and gentlemen, do come up and take your positions. And as they do, I'm going to talk through our lovely panelists. Right. Because, do come up, guys. So we have Andrea Vena. I hope I'm pronouncing Vena correctly. My Italian's not great. Andrea is the Chief Climate and Sustainability Officer of the European Space Agency. He's an expert on business development and strategic analysis, as well as planning and marketing, and he's absolutely passionate about sustainability. We have Charity Whedon. Charity is the Associate Administrator leading NASA's Office of Technology, Policy and Strategy, which is a very, very important department because they provide NASA leadership with advice on policy issues and strategic planning and technology investments. So that is very important. Previously, she was at Astroscale, which is a company which addresses orbital sustainability challenges. So she's passionate about it too. We have Cedric Balti. Cedric is the Director of Innovation and Chief Sustainability Officer at Thales Alenia Space, the industrial aerospace giant. He says that his mission is to develop the innovation culture within Thales Alenia Space, to hatch disruptive ideas and to promote their developments. Now, first of all, I talked about turning space junk into propellant. And we're going to start with Professor Paddy Neumann. Paddy is the Chief Scientist and Head of Research and Development at Neumann Space, a company which he founded, I think in 2016 or 2015. He is an internationally recognized expert in plasma physics and also propulsion. And Neumann have invented the Neumann drive, which basically it's a propulsion system which uses space debris as its propellant. And in 2022, Paddy was named Australian Scientist of the Year at the Australian Space Awards. Congratulations, Paddy. Let's start with you. Obviously, a propulsion system that uses space debris has got to be the definition of a circular economy. What is it, and how does it work, Paddy?
Thank you for the kind introduction. Our system works using similar physics to a pulsed cathodic arc source, or for those not in the field, an electric welder. You strike the arc from a conductive electrode, you make a little bit of this solid electrode into a hot ionized gas, a plasma, and the plasma processes accelerate this plasma downrange as a neutral plasma. The ions and the electrons zoom along and they take away some momentum. The recoil pushes the spacecraft along. We can use anything solid and conductive as propellant. This includes our propellant of choice for our units that we are selling to customers, which uses molybdenum as their propellant. But we've also demonstrated that we can generate thrust from recycled aerospace alloys, such as 6061 aluminium.
So it's very, very important. Good luck with finding the, this of course is a startup business, which makes it really relevant. And I just wanted to point out as well that we've been decided to divide our conversation today into three particular themes. And our first theme is very much about innovation and how we can make the circular economy happen, and also what are some of the challenges that we're facing. Cedric, Andrea, let's go to you. The circular economy is very much about reusing what we've already got, putting back what we've taken out, reusing materials. And how can you apply these principles to space from your perspective, and particularly obviously when you're designing satellites and developing missions?
Thank you, Katie, and good morning, everybody. Indeed, circular economy, it's a basis of sustainability. And as you were pointing out, sustainability is in the three areas. Let's focus first on the area that we have on Earth. On Earth, it's very important that we think or rethink how to design our space products. And this is encompassing, for sure, the first place, the identification of what are the things that you want to improve in terms of environmental impact, for instance. And then when you have identified those areas, what we have called the hotspots, then you can finally decide which type of innovation you want to apply to reduce the environmental impact of that particular area, of that product, or maybe a process, or maybe a material. And the reuse of materials is one of the things that have been done. Just one example is materials, raw materials, and rare earth in particular that are used for solar panels in space. It's a massive use. And as you can imagine, this is a very precious resources. So one of the things that the agency has been pushing forward is the reuse of those rare earths that have been utilized during the process, the industrial process. So there is a circular economy there, and the waste of the industrial process is reused again to reduce by maybe even 80% the material that is used for that kind of industrial process. This is just one example, but the very key thing is that we are rethinking the way in which we design spacecraft and objects that we are going to put in orbit. If we look at the upper layer, so the orbit, this is also a very place where we have to think about how we can reuse things and introduce other principles of the space circular economy. And in particular, one example that I would like to make is the active debris removal. This is something that everybody knows, but now we should think about equipping our spacecraft of something that can be used even in a passive and non-cooperative way for, I would say, in the first place, active debris removal, so taking this object out of an orbit that may be dangerous, but also for maintenance, for reuse of the same object, displacing it in a different orbit. So this is a project that is using a mice adapter that is something that is going to be installed in the 6 Copernicus expanded missions that are under development today. So each of those missions is going to be equipped by this kind of device that will allow in the future the displacement of the space object, of the satellite, in case it is needed, either for debris removal or for change of the orbit and the reutilization of the same spacecraft. So these are the 2 areas that I wanted to make as an example.
Very interesting. So this is looking at a number of strategies there, circular economy principles for rethinking eco-design, repairing in space, etc. Cedric, these are all really important technologies, but they've actually got to be turned into reality. Thales Alenia Space, one of the industries which is researching all of this. What do we actually mean by refueling, by repairing and servicing in space? I mean, it's one thing talking about it. It's not like driving up in your car and refueling your car. You've got an object which is flying around at the speed of a bullet. What are the complexities?
Well, it's true that it's not like driving a car. Being in space, you have just imagine the speed. So first, you need to be able to identify your target. So we're speaking here about active debris removal. And to start with, we'll have non-cooperative objects. In the future, we hope we'll design satellites and objects that will be rather more cooperative, but we need to start cleaning up the orbits. So you need to identify your target. You need to approach your target at a very high speed. Then obviously, you need to dock to your object and then provide the relevant actions to deliver the service. We have a project, for those who are interested, you can go to the European Commission booth, which is called EROS, in which we have developed, we started in 2016, and we have developed, let's say, roughly 3 types of typical mission. One is about transportation, where you will deorbit or reorbit a satellite. So once you've done this, detect your object, approach it, dock it, then you can deorbit or reorbit the satellite or the debris. The second one is about refueling. And of course, you can imagine that you need to be able to interact with the satellites you're connecting to. And the third one is about replacing, which could be repairing at some point also. And that's the type of development we have done since 2016 that will be driving us to a demonstrator in 2028. So I encourage you, if you want to better feel what it means, to go and test this virtual reality experimentation in the European Commission booth.
Well, I would like to just add, actually, that it's really worth visiting the EU booth, which is next to the Thales Linear Space booth, actually, because the demonstration which Cedric talked about, I did it this morning, it's really good. You can actually control the satellite in space. It's a virtual reality demonstration. You can see how you can actually dock and change a battery, I think. Charity, let's move on to NASA's perspective, because we know that there are, I don't know, I think I might be wrong in saying there are some 400 or so missions already planned for the moon over the next 10 years or so. And we're going to be building habitats on the moon. We're going to be needing to reuse materials on the moon. And of course, someday reusing parts. So tell us about NASA's perspective. And I'm guessing that you're using the sort of circularity that you've learned from the ISS as well.
That's right. Thank you. And buongiorno. I hope you're all practicing your buongiornos this week. It's a pleasure to be here. Thank you for the invitation. So circular economy principles are a necessity for a sustained presence outside of Earth orbit. It's just as simple as that. And we're lucky that we've had decades of experience in the space station practicing some of these requirements, like water reclamation. The ISS reclaims over 90% of the water used every time. So that's one example. Another example is repair on the space station. There's something called the Special Purpose Dexterous Maneuver, SPDM, or affectionately known as Dexter, to repair items on the space station, use robotics. So we've had some experience doing this already, but I can tell you we have to take it further if we're going to have a sustained lunar presence. For example, our Moon to Mars strategy, one of the key tenets is about maintainability and reuse. So we need to think about these things because it's too expensive, it's too hard to get mass to orbit. We have to eventually bring everything we need with us on a trip to Mars. If things break, all our consumables need to be brought with us. We need to grow our own plants on the way there. And so this is a really, really important concept to think through and how we can advance that. Now, it doesn't come without challenges, right? And there are several challenges. Think about recycling and repurposing and reusing here on Earth. Just think about that for a minute. It takes a lot of power and processing to turn plastics into reusable, for example, and metals reusable. You need to think about the safety of reusing something that's already been used for a different purpose. So those are the kind of the technical challenges we have that we need to tackle. There's also economic challenges. It's in the name, circular economy. So where's the economy going to come here, right? We still have those challenges here on Earth of materials getting repurposed or and use that in an economy way or economy manner. And so in space, that is doubly so, right? Space is hard and space economy even more so. So thinking about where are the financial incentives here as well. And the last difficulty is the policy piece, right? When you're going to rendezvous with another object or remove it from orbit, there's insurance, liability questions, ownership questions. Here on Earth, we have junkyards, and maybe we lease the land and have a business there. That's not how it works in space, is it? So we have to think through these like policy regulatory things. I want to give a good example that Deputy Administrator Melroy gave earlier this week, and it was really enlightening. She said, packaging is a huge thing. When you're sending things to the space station, it has to be properly packaged so it can work. Maybe it's a tool, right? And that'll come with a lot of foam around it, maybe a box, a lot of packaging. That's going to be a really big problem if we can't think of ways to repurpose, reuse that packaging in orbit, but also on the surface of the moon. Where are we going to put this all? There's no trash heap there. So we're going to have to think of this. So NASA did just announce a Luna Recycle Challenge for this very purpose. You know, articles of clothing, packaging, those solid materials, what can we do with those? How can we reuse them? And so that's a great start. Lots of challenges, but we're starting to think about that.
Yeah, and we're going to put a QR code up later about the Lunar Recycle Challenge so that you can scan it and find out more. Very, very interesting project there. Let's just turn now to our second theme. We wanted to ask, what are the biggest challenges to implementing these kinds of principles in practice, if you like? And you've touched on some of them. But how do we overcome those challenges? And obviously, collaboration has to be vital because we need to use the might of our combined forces in order to make this happen. It's got to be a big global effort, effectively. Neumann Space, Paddy, is a small company with a big idea. You've already managed to fly, which is a big step. Testing your satellite, testing your demonstrator in space, obviously, is hugely important, but challenging. Paddy, you've been collaborating with the Australian Space Agency, I think, and maybe also the French Space Agency, CNES, and US partners, so you've had a lot of collaboration there. We've got a couple of questions coming in. Just tell me, I'm going to come to those questions in a second, but just tell me a little bit about what it's like for startups and some of the challenges you face, and maybe some advice for some of the space agencies and organizations about how they can help.
One of the very first challenges is one of the harder ones to bridge, which is, of course, the credibility gap. If you've just come out as a very new company, coming out with some research behind you, there's a lot of people out there saying a lot of things, making big claims. How you can make sure people can trust what you're saying, can verify what you're verify the potential of what it is you're working on. That's one of the big steps, and we've had a lot of assistance with this, demonstrating our capabilities from early days through integrated prototypes, through collaborative projects. And for anyone out there who's starting this journey, one of the best ways of starting this is get out, talk to people, and make sure you've got good results, hard data to back up the discussions you're having with people who can poke holes in it. And if they keep on trying to poke holes and you've got the good answers, fantastic. Find a place where you get to the, where your answer is, I don't know, I haven't tested that. Do you have any ideas on how we could test it together? So you can build that collaboration, build the cooperation. And if you do this with enough and have enough players in there, it stops being just cooperation and becomes a cooperative ecosystem.
And any thoughts for our two members of the space agencies here that they can pick up on shortly? Anything that you would like them, or did you want to say something, Andrea?
Yes, very many interesting elements are coming up from the discussion. We understand that space systems are not simple systems, are complex systems that are performed by different actors, space agencies, there are companies, there are long supply chains with places in different countries. At least in Europe, we have 22 countries that are part of the European Space Agency. So it is going without saying that collaboration is at the basis of everything. And we cannot do collaboration without sharing information, without sharing best practices. So the initiatives that we have been taking for the Zero Debris Charter, for instance, is one example of collaboration, or the Statement for a Responsible Space Sector that is now counting 70 organizations that have joined the efforts towards more sustainability and more responsibility in the space sector. So this collaboration is fundamental. Sharing experience, looking forward for common solutions, talking each other to see and what can be really improved for the purpose of having a better, responsible and sustainable space. And then there is the support to companies, the support to innovation, to generate new ideas. So opening platforms where we can put ideas on different topics. One is coming from my mind from what you say, the Charity. So the assembly in orbit. So large space structures that necessarily have to be assembled in orbit. How to do it? What are the challenges? How to overcome them? there is a need to a collaborative effort in putting forward ideas, reach at least a technology readiness level that enables companies to go for business. And this is the role of space agency there. So we have to support them, to enable them maybe to be the first customer on this, in this case, and then allowing them to go on the market and sell their products.
Cedric, what about big industries like yours? What are the business opportunities in the field of sustainability? I wonder, you know, how big are the R&D budgets in reality, and how much R&D is actually possible?
Well, I think first what we are tackling, and Thales Alenia Space is very much involved in this, is really to prepare a sustainable future for our space business. I mean, it is somehow at risk. We don't know today the impact of some of the areas, the launchers, the end of life of the satellite when it comes back. So there's really a huge work to be done, and I like a lot the comments on the fact that it is a collaborative approach. I think it's really, we believe that it's totally ecosystemic, so we need to work all together. In Thales Alenia Space, we've been putting in place an innovation approach where we develop the collaborations with other stakeholders. For instance, startups. Maybe you heard about the Space Business Catalyst, where we host startups. We select them based on the sustainability impact they may have, because we'll not be able to do everything on our side as industrials. We need the support from the agencies, we need the creativity from all the players, and we need to move all together towards this circularity. And I think it's very important to keep in mind that the challenge is starting now. It will take years. I spoke about EROS, which is just a technological brick. Started in 2016. We will demonstrate in 2028. It's not so easy to be much quicker than that. And it requires a lot of funds. So definitely we're looking forward to collaborate with all the actors willing to build this circular vision of space, because it's the future of our business. Really, we're standing on this business with a risk, and we need to address it collectively. And just a word, in Thales Alenia Space, we decided to address sustainability through 3 pillars. The first one is engaging and embedding. So engaging our colleagues, but engaging all the ecosystem, embedding all our decision through sustainability. The second pillar is sustainability and circularity. So definitely circularity is in our strategic vision of sustainability. And the third one is act on global challenges. So we can also, through space business, space sector, bring some solutions to the planetary challenges. So we know all these Earth observation satellites, which are already providing value to the planet and humanity. We are also investigating some other maybe crazy ideas today, but maybe one day it will make sense. So for instance, maybe you heard about data centers in space, the ASCENT project, where we went to study whether it would make sense in terms of sustainability. So we're not, for instance, at this stage in developing solutions. We want to understand whether it could bring a solution to the digital development on Earth. So that's examples. And again, it's totally ecosystemic, so we are really calling and gathering all the actors willing to move, and we are part of them, and we want to be part of this game and challenge.
And let's turn to you, Charity. NASA published this year the first volume of its space sustainability strategy. What would you say NASA's research is showing us in terms of the benefits, if you like, and the incentives, and how the benefits can effectively outweigh the costs of implementing these kinds of principles?
Sure. Well, let me give you a little primer on the strategy. First, space sustainability is not just a NASA thing. It's not just a United States thing, and it's not just a government thing. It's all of us together, and that's why the collaboration is so important here. So the strategy was released last spring. It was meant to highlight and improve NASA in its future and its role in space sustainability. And it has 6 goals. The first goal is really defining what is the framework we're working with here. What are the various knobs and dials we can turn towards a future with long-term space sustainability. And that's a hard problem, actually, on its own, because there's so many interlocking kind of codependencies when we're making decisions. Is this safe or not in orbit? Goal number 2 is about minimizing those uncertainties. So finding the gaps, minimize those uncertainties, and then prioritize what we do first. It's going to be complicated, but we can prioritize and work our way through this. Goal number 3 is about lowering those barriers, and we identify the uncertainties, now we go and fix them. Now we can invest smartly in the technologies that will drive forward space sustainability. Now we can, do more research and economic studies, for example, on pulling in the economic elements of space sustainability. Goal number 4 is updating those internal NASA policies so that we're in line with our own strategies. So kind of updating and looking internally there. But goal number 5, I want to kind of sit on this for a little bit. That's about continuing to improve coordination and collaboration outside the agency. So this means with our interagency partners, again, it's not just a NASA thing, it's about sharing best practices, models, data, and tools, making sure we incorporate technical advancements by the broader space community as well. And here, I want to put a plug for another element, which is interoperability and standards as a key element of the circular economy principles you see up there. This is going to be important, not just from a safety standpoint, but if we're going to drive down costs, interoperability and standards are really important. Goal number 6 is about improving internal organization to support. And NASA just announced a new director of space sustainability to pull all these pieces together, take this really complex problem, and start to implement solutions towards it.
Thank you, Charity. And I want to also bring out a couple of questions here, because we're getting some questions in about ownership of space junk. Maybe this is one that you could address, Paddy. We've got questions around whether if you use space junk as a propellant, do you need permission from the owner? And what do you do if ownership cannot be determined?
Yeah, excellent questions. And the short answer is I don't know, because no one's done it yet, really. A better answer would be we want to be in the responsible space rubbish junk disposal business, not the space piracy business. All fun and games about putting on eye patches, getting parrots, and going and like grabbing junk and like getting rid of it. We all know that junk's a problem, but one person's garbage truck is somebody else's dual-use, potentially sensitive application of technology. The people that we have been collaborating with, and to build on a previous point, the one great way of starting the collaboration method is NASA's and the US government more generally's SBIR program. We've been working with Cislunar Industries of Colorado, as well as Astroscale and Sierra on a couple of projects. The folks at Cislunar, the ones building the metal reshaping and reforming electromagnetic foundry, and their plan, as well as our plan, is to talk to the owners of objects where that ownership can be incontrovertibly established, so that we talk to company X who's launched this old satellite, or whoever contracted for this mission that has a second stage on orbit. That ownership needs to be recorded as part of the launching convention. The liability remains with the launching state, so the launching state has probably an incentive to make sure that liabilities associated with those objects can be dealt with. These liabilities can't be abandoned. This is part of the treaties. But if the object that could cause those liabilities to come home to roost is reprocessed, is made into something else, that could help out both, and bottom line on an insurance risk, definitely help a risk register, definitely help move things around in space.
And we're getting a few questions as well about the impact of mega constellations in LEO and how we should be dealing with those. Does anybody want to pick up on that?
Yes, it's an excellent question, and it's very much linked with what we were discussing before. So for sure, mega constellations are implying many, many flights up, so crossing the atmosphere, burning something in the up way.
Can you keep the mic close, Andrea? Thank you.
Sure. But also coming back, so many of the satellites of mega constellation, we are talking about thousands and tens of thousands of satellites that are going to be there, up there. They are going to re-enter the atmosphere sooner or later because they are going to malfunction, they are going to have problems, and this is already happening. And the re-entry in the atmosphere is generating something, is burning materials. We must be sure that those materials are good for our atmosphere. First of all, we have to understand which are the good materials and which are not the good materials. So, but we are joining efforts with other peer space agencies to understand that. And then this should be carefully regulated, because it is not that by burning in the atmosphere satellites we have solved the problem. We may generate other problems for our atmosphere.
Katie, I'll add to that. First, I'll say NASA is not a regulator, but what we are, and what we do have, is technical competency. And you can leverage NASA's technical competency in developing new tech that can help solve congestion in orbit. There is a program called Starling, with the ING, that is testing out autonomy between two separate constellations. And so I think that's an important thing of developing the technology piece in addition to highlighting the policy piece.
And just one final question before we move on to our third topic is around sorry, let me find it. Okay, one of the challenges to creating disruptive technology, this is from Dr. Natasha Nicholson, is that the return on investment for investors will be far down the road and therefore unattractive propositions. What opportunities are there for small startups with big ideas backed by science? Would somebody like to take that?
I'll just repeat something that Patty said about the SBIR program. Those, I mean, it's not just a NASA thing. Other nations have, small business programs to support great novel ideas that just need a little bit of funding to get off the ground. So, that is a positive thing to bring this innovation to light and further it down the TRL chain.
If I can, at ESA, we have an open space innovation platform that is always open to new ideas and proposals that can come from small companies, big companies, academia, even single citizens that have something in mind that would like to propose it and go forward to it. So it's really a place where things can be put. And it is an open platform. There are several calls that are ongoing on different topics, and sustainability is certainly one of the major topics that are dealt with there.
Thank you. Cedric, did you want to say something before I... Yes, go ahead, please.
I may combine it with your question.
Well, I wanted to move on to our third topic, which is how can we learn from all this, all the technologies that we're developing in space, and maybe use some of these on Earth and inspire us on Earth, whether that's technology transfer or other things. And I wanted to start with you, Cedric, and ask you what sort of business opportunities does Thales Alenia Space see in applying space solutions to achieve sustainability goals on Earth?
Okay, in terms of business opportunities, I think circularity, circularity is per se an opportunity. We need absolutely to develop the means to circularize, whether on Earth, whether in space, whether for life in space or robotics. So everything has to be done. I mean, so many things have to be done that it is a business opportunity for those who will be moving. I wanted to echo also to the question before, again reminding that we have this Space Business Catalyst, which is an accelerator in which we host startups, let's say, or small companies that are complementary to what we are doing and could bring an interesting brick to this vision and roadmap that we are trying to tackle. And I think one of the big challenges of the circular economy is how, and it's the same on the Earth, I think that's what you said at the beginning, but it's very important to try to bring value at the end of the value chain, so you re-inject value at the beginning of the value chain. And that's really a challenge for all the industries, and I think we should tackle this. So there's not only a technical issue here, there is a business model issue, value chain issue, legal issue that we need to tackle, and we need to work all this in parallel. It's really an overall, again, ecosystemic work to be done all together. So at least on Thales Alenia Space, what we are willing is really to open as much as we can and to listen and develop the interaction and the cooperation where it can support the development of this new business field, let's say.
Charity, any thoughts? You mentioned the recycling, moon recycling program. Any other thoughts on using space technologies on Earth?
Right, I feel I'm in really good company here because I think you all know the benefits that space gives us here on planet Earth. And so, you know, there's so many examples here, and it really enriches our lives. Even back in the Apollo program, water purification technology became a thing, and we were using that. We were using that for dialysis, of separating out toxins from the good stuff. And so, you know, our activities in space do support us here on Earth. One good example you can take from the ISS is indoor farming, vertical farming, and how we can leverage that here on Earth as well. Because we're going to need to have these sort of technologies as we go to the moon and Mars and beyond. So think about the ISS as a microgravity test bed as well. What do we not know? So here's the things that we found out from, you know, Apollo program, ISS program, and we're leveraging it in our everyday lives now. And now, like, what can we discover in a new microgravity platform for recycling plastics? Right? There's so much potential here of leveraging those platforms. And then just think of what Artemis is going to bring to us here on Earth. If all these technologies that we've developed so far have reap benefits here on Earth, I think we're in a path where it's going to continue.
Paddy, can you use space debris to propel anything on Earth?
Yes and no. The thruster that we're developing is an electric propulsion system, so quite low thrust, very low thruster power systems, and needs to operate in a high vacuum. When we're going through the process of integrating with partners, one of the questions we sometimes get asked is, can you accidentally fire it at atmosphere? And you can. It sounds like a fuse wire exploding because it's metal getting vaporized and expanding out. As for propelling things with junk, well, if you sit on the computer chair and you throw some rubbish away, you'll get recoil, so I suppose you could do that. The system, however, it derives from an industrial coating machine, which gets used for thin film deposition and plasma vapor deposition to grow things like indium tin oxide on glass for smartphones or diamond-like carbon onto steels for diamond drill bits. So there's a lot of technology transfer from terrestrial applications going into space applications, and potentially from space free space applications onto surface applications on the moon, on asteroids, on Mars for manufacture and process.
Andrea, any thoughts about technologies that can be used on our planet?
Absolutely, yes. Dwelling a bit more on the experience that we have had and we are still having in the International Space Station, as Charity was mentioning. For sure, water reuse has generated a lot of spin-offs in different fields. The dialysis was one mentioned by you, but I would try to pick up one that is maybe less known, and it is very much oriented in saving precious resources on Earth in industrial processes. So the same technology that has been developed in for the International Space Station, which is called MELISSA, it's a project that is dated 30 years ago when the space station was thought at the very beginning. It stands for Microecological Life Support System Alternative. So this same technology is today used for brewery. So company a company, specific company in the Netherlands, is reducing by 80% the use of water, because to brew beers, you use tons and tons of water. So this amount of water is reduced thanks to a technology that has been developed for the International Space Station. And the second example is about another precious resource that is energy and is heating or cooling. Using microalgae that have been cultivated in the International Space Station, we can make the so-called biofacade for buildings. And those biofacades are actually green plants, algae facades that are keeping cold in the summer inside and keeping the warm inside in winter. So it's a very good isolator. So it's keeping and reusing the energy that is generated by the plants. So these are two examples that are matching sustainability, circular economy, and space, very much of space.
Cedric, you wanted to add something?
Yeah, I think there was so yeah, indeed, Melissa is one of the projects I wanted to share, and we are involved thanks to ESA, and it's really a great project that we drive here in Turin on our side. And I wanted also to share that there has been things done, but there are things ongoing or which will come in the future. For instance, maybe you heard about Space Cargo and Space Rider, which is a satellite going into zero-G, enables to do in-space manufacturing. So for instance, it seems that it demonstrated the capability to have more vineyards with a higher resistance to heating periods, for instance, or pharmaceutical companies also who have interest in leveraging microgravity for molecular operations. So that's the type of things also that space can bring, and cooperation again between big groups like us and smaller companies, startups like Space Pharma, Space Cargo, this type of factors. So I think we're not at the end of what space can bring to Earth, and that's great. And we need to work on circularity to make it happen over the long term.
Now, we've asked our guests to bring... oh, I had hoped to have a slide here. Nope. Oh, yes, here we go. We asked our guests to bring some platforms for you to have a look at, and I highly recommend that you scan the codes here. The first one is the large space structure mentioned. That's the OSIP campaign. Take a look at that. Space Business Catalyst, which is Thales Alenia Space. Have a look at that one. And here is the NASA Lunar Recycle, which Charity mentioned. If anyone's got any bright ideas in the room, highly recommend you take a look at this and see if you can meet the challenge. Now, I want to apologize to all the fantastic questions that have come in. I'd love to ask our panel to address them all, but we just simply haven't had time. We've got 2 minutes left, and so I'm going to ask you, all 4 of you, in 30 seconds, that's the challenge, can you meet it, to sum up and give us your one key thought. What would you like folk here to take away with them in 30 seconds, folks? Starting, Paddy, with you.
There's a lot of resources that people have put a lot of energy and a lot of capital into putting in space. Those resources don't only have to be used once, they can be used a lot of time. Recycling is something that we've been doing for centuries for various applications. One of the old English sayings is, where there's muck, there's brass, where there's brass, there's gold. People have been mining sewers to find things for centuries. If someone's already refined it into metal, all you have to do is reshape it and make another use of it. These are things we can do, and these are things we're working on now. Andrea.
Very much in line with that. Space is an environment where resources are very precious, are very scarce. It's difficult to bring them up there. Therefore, it is a source of inspiration for the same thing on Earth. So we can take a lot of lessons on how we approach space systems on Earth, where resources are becoming scarce and have to be preserved.
Charity.
Necessity is the mother of invention. So despite all the challenges we've outlined here today, because we are going back to the moon, we're going to the moon, Mars, and beyond, we're going to develop these technologies. We're going to figure out the financial aspects. We're going to work through those policy and regulatory issues. So that's my message.
Cedric.
Yeah, collaborating on space circular economy is the title of the panel, and I really encourage you to come and join us, if I may. We need all the energy, investments, of course, the good ideas, and I think it's a tremendous space of creativity, of innovation.
That's my time. I've the end of the panel. Keep going. Keep
no,
going.
Of innovation on which we need all the good ideas, the players who are willing to be positive and to put themselves on the moves with all of us. I think we need to collaborate, all of us, and do the best out of it. But that's really a great challenge that we'll be glad to share with those who are willing to move forward.
Right, well, I would like to say a couple of thank yous. We've come to the end, but I want to say a massive thank you to the European Space Agency for organising this panel, this really, really important panel. They're very keen to gather organisations together to make the principles of the circular economy a reality and see how we can pioneer that and implement it. And last of all, I'd like to say a huge thank you to Andrea Vena, Charity Whedon, Paddy Neumann, and Cedric Balti. A massive round of applause to them and to you for being with us. Thank you.
Hello. Yes, good afternoon, ladies and gentlemen. Hello. No? Hello. Yes, good. Thank you. Thank you very much. Good afternoon, ladies and gentlemen. In this session where we are going to see that AIDAA student team challenge for the Global Sustainability Awards. And to start this session, I invite Dr. Professor Erasmo Carrera, who is the president for AIDAA. Thank you. As well, I will invite Dr. Enrico Zeppino, who is the Executive Project Manager for AIDAA, please. To start with, I request Professor Carrera to have some words about this session, please. So these, okay. Okay, perfect.
So I also call on stage first Mariana and Francesca. So please, you have to come on stage. Yeah. Okay, so let me be. I will be very short. And you know what? I want to give you a message that this is the first time we have GNF devoted to student challenge here at IAC, and this is. Was a proposal from AIDA, and of course, very well received by IAF, so they really approved. So for the first time, we will have a challenge, you know, for the students. This is really the place where the students can have a, you know, a shade to really act directly on at IAC here in Milan. And the two Francesca and Mariana, they are both PhD students, and of course we need to give a little bit, you know, of hierarchy, and then we put some professors in it. Okay, so just, but they've done most of the work, and. We hope that this will be a first possibility, and we will go ahead in the next edition of AIC in Sydney, then in Antalya, and then probably in Poznan. Okay, thank you.
Thank you, Professor Carrera. Now I'll invite Dr. Zeppino to have some words. Thank you.
Okay. Welcome, everybody, to this session. We are quite proud to be here today because this is the last step of this long travel that started some months ago. Actually, we are here today because actually as an association we started some years ago planning to have a very special year. We call it Aerospace Italy 2024 because this year we actually host many of the most important conferences in Italy. The one from Aeroacoustic in June in Rome, that is the most important, most prominent events in aeroacoustic in the world. And then in September we have ICAS in Florence, that is actually somehow the AIC for the aeronautical field. And then today we are here at the AIC in Milan to close this, for us, very intense, but also very nice here. As you know, we are an association. We have been founded more than 100 years ago, so we are quite old, and we are happy to be still active now in order and to be able to organize such big event. We are distributed in all Italy. We have our journal, that is our Tecnica Miseria Spazio. Even this journal is 100 years old and something more. That is something special. There are not so many journals that have this history. And for sure, we are composed by some technical committee. We are courses and actually provide a lot of services to disseminate the aerospace, the aerospace in the country. About the student challenge, we tried, the objective was to try to really spread this initiative all over the world. So we tried to create a network. For sure, we start from the Italian team, and then the European, and then the team around the world. And the idea was to create something like a challenge to bring the most, the team that demonstrated to be more, to propose the better project, to bring them at the IAC. So actually, there was a big work in the writing the proposal, the call for the challenge, and so on. And at the end of the day, what we have, that we have 23 teams, sorry. For sure, most of them were from Europe. For sure, geographically it is easier, but we were happy also to have 2 teams from America, 2 American teams, and 3 from Asia. So actually, this was quite good for us to have a very good representation of the geography. At the beginning, we selected actually more teams. Almost 70 teams applied to be here today. At the end, we selected the best of 23 in order to support them to come here to Milan and to present their work. And now, we had yesterday a dedicated IP session, so we were able to evaluate the work, and today we are here to close this path and to award the team that have been considered the best in different categories that we will see later on. This is a little bit the picture of the team and the provenience. So as you can see, it's a very good geographical distribution. We are pretty proud of that. We are able to cover a large part of the world. For sure, in the next edition, we hope this can be also better. So, with this, I can close. I can once again give the microphone to to my colleague in order to have the award ceremony. So thank you.
Thank you, Professor Zappino. So in fact, there are in total 3 technical, you can say, prizes. And there are around 5 we have special prizes. For the 3 technical prizes, I'm just going to announce them, but these are not in a row just like number 1, number 2, number 3. So we are going to call them, and then they are going to present for 5 minutes, and then finally we are going to see based on their quality of the work and the quality of the presentation. Then we are going to announce at the end of this session that who is number 1, who is number 2, and who is number 3. So first of all, yes, these 3 teams who are you can say the finalist teams. So the Diana from Italy. Then we have Wonder Mercury from Costa Rica. And then the 3rd finalist is Diana Ostrasis from Germany. So they are going to present now. So yes, these teams, one by one, they are going to come here for 5 minutes. They are going to present. Is it like this?
So, Diana Ostrasis, it's your turn. A very short presentation, 5 minutes.
5 minutes, let's go.
It's your
to pass. So, hello everybody. We are Diana Strauss. For a couple of years, we have been developing our project of self-sustainable moon village that covers the integral solution. We do not center in one aspect or one topic especially. We center in the integral solution of the whole. And we started 3 years ago in the competition Space Station Design Workshop, which is a competition that is held annually in the University of Stuttgart, in which 2 teams compete against each other to come out with the best concept of a main space station. From that initial concept that was quite simple, we have been really iterating during the different conferences, different congresses, adding more modules, adding more collaborations to our capabilities with different collaborations with the University of Stuttgart, different startups, and like our latest collaboration with the startup Immensus from Stuttgart also, which is aiming to do lunar prospection of the lunar geological prospection. From that on, here you can have a glance of all our set of different modules that are supporting the main station that we are developing. And it has to be mentioned that all the concept right now is oversized because we are, and as one of our collaborations with the Institute of Space Systems of Stuttgart, we are supporting the research of the sunshade, interplanetary sunshade system, which is really extensive material resource eater. So our concept is we have developed this idea for the habitation, in which we are using mainly in situ reutilization of the lunar resources, regolith, different metals we can find there, different minerals, to get to this solution, architectural solution, that we will be built using 3D printing techniques and other manufacturing facilities that we will bring there. All of this with the goal of being as self-sustainable as possible in the long run of the project. And for this, we have not only to center where the astronauts and the people is going to live there, but also to support them. So we have built also a system of life support systems with recyclable air, water, and even a little food, a bit of food production with different crops techniques that can be available. All of this supporting, as we mentioned before, the International Planetary Sunshade, which is a project from the University of Stuttgart, which aims to reduce the radiation coming to the Earth. So we want to help to develop this concept to reduce the global warming on the planet. The challenge that has this structure is that it's really power intensive to fit in terms of resources, and for that, we have developed an extensive network of transportation systems around the crater in which we are set in the South Pole, as well with different models of rovers to manage to excavate the materials required, and an extensive network of manufacturing facilities that will be set initially, will be the hardest part of the logistical challenge, but then after that will allow us to be as self-sustainable in the long run. But this also comes with another challenges, like we have mentioned facilities, we have mentioned life support system, we have mentioned all the whole infrastructure for manufacturing and transport. This is going to be power with a lot of solar panels that you can say, okay, this is not self-sustainable because you have to bring the materials from the earth. Not exactly. We have one of our collaborators, we have been generating studying the technology of the perovskite cells, which allow us, we have researched that this, it can be manufactured using the lunar resources. So in that way, we can, for the initial stages of the project, a lot of materials will be needed. But after that, once we start to manufacture those perovskite cells, we will achieve the goal of the self-sustainability. Supporting these power necessities, we also have the constellation Zeus, which is a collaboration with the SGAC, which will help us to deliver more power due to the limitations in the South Pole, to the incidence limitation of the South Pole of the solar rays, beaming part of that power received in orbit to the solar arrays on the ground. And also we have realized that there are other challenges, like the communication for different rover systems. What? 1 minute? Okay, no problem. Different rover systems, and something sounds so simple that could be so challengeful there, like having an astronaut or a scientific personnel ill or getting ill in such a hostile environment, having a reliable communication system will allow us to get something like as essential as telemedicine to be ensured to sort it out the problem as fast as possible. So this is our concept. This is our integral view of the Moon Village. We are Team Astreus with our Diana Moon Village concept for sustainable habitation of the Moon and research. Thank you.
And now, Diana team.
Okay, so I'll be as brief as possible. And so, how do I? Okay. Okay, so we are Team Diana from Politecnico di Torino, and we are a student team, and here are some photos of the team in various competition and occasion from the up left, where the team started in 2008, to the last competition here, bottom right. And here are, let's say, a recap of our 4 rovers that we built during the years. So we started with Amalia for the Google Lunar X Prize, going to T0R0. After the closure of the Google Lunar X Prize, we decided to switch to student competition with T0R0, then Trinity, and then Ardito, which you can also see here in INC. Okay, and here you can see also, let's say, the footprint of the Diana at its beginning, where Paolo Bellutta, the driver of the rover Spirit, was driving Amalia with Professor Emeritus Giancarlo Genta, our founder. And we as a team, we participate in a European Rover Challenge, where we are called to complete a series of tasks with our rovers. And we also participate in commercial calls from ESA with other entities in our university, as in this case, where we provided a platform for the challenge, while other teams were providing the payloads. And this, oops, okay. Along the, let's say, technical activities, we are active also with a lot of events. So starting from INC 2022, 2023 in Baku, and now in Milan. We also participated in some, let's say, event in our city in Turin, and in television, let's say, scientific program, mainly. Okay. Here is a, let's say, here we summarized our main sponsor, and this is a thing that we care a lot, because we also try to have a, let's say, this is also a sustainable aspect if you want. We try to be in touch with local companies from Piedmont and Italy in general, to also reduce the cost and the transport and the waste made for our projects. And here is one of a few main sponsors. Here you can see the rover, our last rover in the Altec Mars Terrain facility in Turin, and in together with Thales Alenia Space, and our other activities with our sponsors. So here, very briefly, we are a quite big team with a lot of students and a lot of different background areas. And we also value a lot the, let's say, educational aspect, and that's why we have the most students from the bachelor degree. So our proposed idea for this challenge was a modular platform to be declined, let's say, sustainability-wise, mainly in 3 topics. So the first topic is that having a modular platform helped us, for real, to build a rover with the minimum waste, because we can change modules without wasting the old ones, which are still working. And having a modular rover also enabled us to mount different payloads. So one rover could accomplish different missions, reducing also the number of systems needed for a single mission. And in our, let's say, vision is also considered the collaboration of different rovers, so that a swarm of rovers could collaborate and accomplish a wider number of missions, reducing also the effort needed for production, for designing, and this is all. Thanks for your attention.
And now, Wonder Mercury team from Costa Rica.
Good afternoon, ladies and gentlemen. My name is Daniela Duran. We come as a team from Costa Rica. We came here presenting a conceptual rover that is called the Maran rover. Its name is Medical Assistant Rover in Autonomous Network. This rover, its main purpose is to serve the astronauts in the moon or in Mars or in any planet that we want to go in medical assistance, because the rover will have a software that is called AMTAVI, that is also a project from us, that is a database of the medical issues that the astronaut have. Also, the Gloxy, is the part that is going to give the oxygen in case the astronaut is out of it. And also, ACASNet, that ACASNet is our project for traduction for the astronauts, because we know that not everyone talks English, not everyone talks Spanish, so we need something to translate, and the rover needs to have that. The rover will serve the astronauts in any emergency, of course, not in a surgery or anything that is out of hand, because that's something that a doctor should do. The rover will give assistance in case of a flu, a headache, something that the astronaut, he doesn't need to move from what he's doing. The rover will go to the astronaut, and the astronaut will not lose any time. So that's why we're trying to make this so it's efficient and is very necessary, because health, where we are, health needs to be there, and this rover will help every astronaut in any planet that we will be. So thank you very much.
Thank you very much. Meanwhile, the jury is going to decide about who is number 1, number 2, and number 3. We are going to announce here some special awards, starting with 340 votes. The winner of the Voice of IAC 2024 Community Award is going to Thirst from Italy. Yes, please. Thirst team from Italy. So, Thrust. Please. Yes, please. Oh, that's okay. Great. Thank you. Now the winning team of the Sustainability Pioneer Award is going to Starust 5 from Netherlands. Starust. Thank you. And the winning team for the Multi-Impact Innovation Award is going to ARES Space from Mexico. Perfect. The winning team of the Outstanding Team Award goes to SEM CubeSat from Saudi Arabia. Thank you. The best team that represents the 3G plus geography, gender, and generation is going to the Politio rocket team from Italy. So first of all,
Third, second, and
first, okay, good. Yes, thank you very much. And now the jury have already decided that who will be number 3, number 2, and number 1. So I'm going to announce in the same order. The third prize, the technical award, goes to Diana from Italy.
Stiamo sotto.
The second technical award goes to Diana from Germany. Thank you. And of course, the first prize will go to Wonder Mercury from Costa Rica.
In the photo, he's going to take a picture.
Thank you. With this, we end this session. Thank you very much for having it. Thank you.
Hello. Yes. Good afternoon, ladies and gentlemen. On behalf of the International Astronautical Federation, we're happy to welcome you to this GNF Sessions 2024 Humans in Space, Multiplanetary Human Life Enabler. To provide some opening remarks, it is my great pleasure to welcome on stage Clay Mowry, the IAF President.
Thank you, Isabella. Good afternoon, ladies and gentlemen. It's a pleasure to be here. Thank you for joining us for this historic 75th International Astronautical Congress here in Milan. We've broken all the records. I can confirm we're well over 11,000 registered delegates. We expect another 3,000 plus tomorrow on Public Day. So really, it's been a pleasure to preside over this meeting of our space family and watch it grow. So we're glad you're here. It's my pleasure to give you a little bit of an introduction to this GNF this afternoon, which is a subject that I've been paying very close attention to over the past few years, and really, I think, one of the more fascinating subjects that we're talking about in space today, which is how do we utilize and how do we understand both humans long-term in space. So if you think about, by the way, what we're going to be talking about at the next IAC, when we get to Sydney, they've talked about this very point, which is ensuring that humans can live safely, securely, healthily, that's not a word. They can be healthy living off planet, yeah? So this is one of the areas that we're going to talk about this afternoon. And as well, how do we use the technology and evolution using microgravity or zero gravity or even lunar gravity or Mars gravity to be able to do things that we cannot fabricate here on Earth, or we can do better in space or uniquely in space. So these are things like growing organs in space, other things we can do biologically with that zero gravity affords that we can't do here in the 1G world that we live in right now here on planet Earth. So there's been a lot of promise in this area. And there's a lot of interest in it from companies outside of our space sector that are thinking about how can they leverage the capability. What's been really constraining in this area for a long time was kind of how long it takes to get up on the ISS, how hard it is to build something scientifically and then be able to get that data back and actually make a business out of it. Or, not to say that the National Lab isn't trying, they're not doing good stuff on the ISS. There's been an amazing amount of research. JAXA, ESA, US, NASA has been trying to do this. But there's, I think, what we see that's coming with a lot of the commercial operators in low Earth orbit is now the ability to do this very rapidly. And also to do it in a way where the approach can be quite innovative and not restricted by bandwidth, for instance, in orbit, using laser communications, using Starlink and other platforms to be able to get data down, using computing, edge computing and other platforms to be able to take this data and do some things. So it's really a very exciting time. We appreciate Boryung, who's one of our silver sponsors here, to take a focus on this really interesting and exciting topic. These guys, I think, have had an amazing presence here at the IAC this week, and we're really happy that they're here to join and help talk about this. So thank you guys for sponsoring. We appreciate it, and I'm really proud to have you here. And please, Jay, come up. The CEO of Boryung is here with us today. Please come on up.
Thank you for the quick introduction, Clay. And it's day 3 of IAC, and this is my 4th time coming up to a podium and give this presentation. And since we only have 30 minutes, I really want to save the time for the panel because we do have such a wonderful panel here. So I want to listen to them. So I'll be really, really quick on explaining what we're doing. So we call ourselves Multiplanetary Human Life Enabler. Not just us, but the partners that who are working with us. So SpaceX, Axiom, and Intuitive Machines, companies like them are building the infrastructures that is necessary for us to go beyond Earth. And what we're trying to do is to take advantage of the infrastructures that are building and send more people there, and for the people and humanity to function and live and thrive as a human in different places in space. So how do we know that? It is important because our company founded as a pharmacy a long time ago, almost 7 years ago, as my grandfather is a founder. And the essence of pharmacy and the pharmaceutical business is to take care of human health on Earth. And we're just taking that to that beyond Earth. And we understand that there has been a tremendous underinvestment when it comes to human health in space and an opportunity to leverage the different environment that we have in microgravity and in space. So because we already know through the works of NASA and many space agencies around the world that we already know about the potential problems that we might face. And in order to, by being involved in resolving these issues, we will be able to understand the physiology of our body itself, which will eventually lead to better treatments or better way of treating people down on Earth. So this is how I explain what we do in our company. So in different places in space, we will face very different issues in our body. So in order to solve them, we bring together partners around the world. I call them problem seekers and problem solvers, to gather the problems that we will face and provide the solutions. And second, we also want to work with the partners to prepare them to launch their research activities and return them safely on Earth to analyze it and maybe lead it to the products to market. And thirdly and lastly, we work closely with our partners to create and secure the infrastructures that are necessary to conduct these research activities in space. So that's what we do. And it will be necessary, and more than necessary, it will be very significant for everyone around the world, because we know that more of us will be going to space and spend more time, go there more often, and go further. So we really need to be prepared. So that's what we're doing. And I really want to appreciate the work that our team has put on to have this presence in IAC, and really want to thank IAF for the support. And for now, I want to introduce Jack from my company to moderate this session. Thank you very much.
Good afternoon, everyone. I'm really happy to be here today, and that I'll be your moderator. My name is Jack Lim. I'm the head of New Portfolio Investment Group, and I was very fortunate to lead the space healthcare, our initiative, which is called Humans in Space Program, from the beginning. And we started 2.5 years ago. Mostly, we try to be the global space initiative, but we initially focused on more like the United States base, and then we luckily get connected with NASA. But now we start having our relationship with the ESA, and then through this IAC opportunity, we have a more chance to connect with the European experts. So here today, we're going to talk about more Humans in Space program, and also how Europeans think about and what European expertise has studied about space healthcare previously. So I'd like to introduce on our panel today. Please, round of applause after each I introduce our esteemed guest today. So first one, Dr. Jens Jordan. He's the director of Institute of Aerospace Medicine at DLR. And Jens and DLR are already part of Humans in Space ecosystem. Ladies and gentlemen, Jens Jordan. And our next guest, Audrey Batia. She's the executive director of MEDIS, the Institute for Space Physiology and Medicine, an institute really leading translation of space health research into application in Europe. And Audrey has been part of Humans in Space since the beginning. Audrey? And our third guest, Dr. Jonathan Scott. Jonathan is the group leader at the ESA Space Medicine team. ESA's space medicine is based in European Astronaut Center, where they support astronaut mission operation, including biomedical engineering. Please. and our that last guest, Dr. Serena Basili. Dr. Serena Basili is involved in orbital and suborbital human spaceflight activities in Italian Space Agency, and she was actively engaged in the commercial mission AX Mission 3. All right. So, like I just explained, we are having a Humans in Space program, which is about gathering different ideas in terms of tackling a problem in astronaut health in space, and also using microgravity condition to solve all different kind of health problems. And we gather those incredible ideas into our platform, and we connect them to right partners, right expertise, and then Boryong as main sponsor, we continuously fund those so that those ideas can be accelerating to the development. So that's what we have done from the beginning, 2022. And luckily, we can connect it through the IAC this time, especially the Boryong was the first, became the IF member 2024. And then being the first presence in IAC is a very good opportunity to get connected with the European experts. So like I explained about the human healthcare, but I think we're going to talk about today more about the European expertise about space healthcare previously. So I'd like to ask a question first, Dr. Jens Jordan. I think Jens Jordan has been the part of our humans in space ecosystem, and Boryong has MOU with the DLR yesterday as well. And then, so DLR seems to be very specialized in targeting space healthcare and to improve human health in space and on Earth. So, but also DLR has a very good facility to have an experiment internally in space agency level. So can you explain about what some area targeting DLR specializing, and then what kind of infrastructure facility that you guys have as well?
Yes, Jack, thank you. I think the main areas we are working on, of course, with our friends and colleagues from other centers, is we really try to enable safe and healthy space exploration, which will face completely new challenges that we haven't really faced in the past in low Earth orbit. I guess the second part that we are really interested in is to make low Earth orbit a safe place to live and work. So I think in the future, more and more people will travel to low Earth orbit, will work there, will have a job in low Earth orbit. So occupational health becomes an important topic. It will be a lot more inclusive than space travel nowadays, people with health limitations. So that's the second area we are interested in. We always try to link space and Earth. So we conduct research, or the research findings and technologies that we develop for people in space are translated to improve the lives of patients on Earth. And I guess the last part that we're really interested in is, let's say, the future economy in low Earth orbit, let's say facilities where you can conduct research, develop products for biomedical or biotechnology purposes. How can we participate in that part? And to do all that, we have a relatively broad research and development program, covering all the, let's say, health areas that are important, ranging from cardiovascular, muscle and skeletal, radiation, psychology, so a broad range of areas and expertise. And we have very, let's say, unique facilities to conduct this research. So I guess the most visible facility in Cologne is probably the NVHAP facility, where we conduct simulation studies in humans, bed rest studies, in the future isolation studies, but now also where we also have facilities to change atmosphere conditions and other environmental conditions that are relevant for people in space. And we combine this with a lot of, let's say, expertise in conducting these studies. You need the facility, but you also need the people with the expertise. But we also have other facilities, for example, the we are intimately involved in biological research as part of the Morpheus program, Sounding Rocket program. So how can we bring biological experiments and test them faster in space? So these are some of the facilities that we have, or some of the programs.
Would you also share a recent experiment that has been conducted on your team as well?
Yeah, so I'm not sure how much time you have, because there's so much exciting stuff going on, and right now we are very, very proud that right now the NASA battery study is running at our center that focuses on sensory motor dysfunction, which is a major problem. Just imagine you are in weightlessness for a long time, land on the moon, trip, fall. I mean, that's really could be life-threatening, and how can we prevent that? And that's part of the study, and we are very proud to be a center for this NASA study. So that's an example of an ongoing study.
Okay, thank you very much. Audrey, I think we know how important METIS has been critical working with the ESA and then solving all different kind of space healthcare problem. But for the audience, those who might not be familiar with the METIS, can you share a little bit about the role of METIS? And then the similar question to Jordan was, what kind of space healthcare been focusing on your institution?
Yeah, hello everyone. So I'm the director of METIS, which is the French Institute for Space Physiology and Medicine. We're located south of France, and we were created more than 35 years ago by the French Space Agency and the Toulouse University Hospital, one of the top-level hospitals in France, with two main missions. The first one is to provide expertise in the field of space physiology and medicine, not only internally, but with a very wide network of partners, both academic and industrial partners. And the second mission, which is also really important, is to try to accelerate some innovation for the benefits of patients, either through the links with space exploration or with other space assets utilization, like satellite services, satellite data. So we have three main activities. The first one is dedicated to support to space mission, so medical follow-up of the crew, but also support for science and microgravity in the field of life sciences. We also do clinical research along with our colleagues from Germany, and of course in an integrated way, which is managed by ESA. So we have a clinical research facility within the hospital where we do bed rest study, tri-immersion study, and also studies outside the space field. And last but not least, we have this innovation department where we really try to make the link between the space and the health ecosystem, trying to use space challenges, space environments, other space assets to try to accelerate innovations for the benefits of patients. So of course, innovation that may contribute to crew health maintenance for future mission, but also other aspects for Earth applications.
Thank you very much. I'll get to ask more questions after introduction on other panels today, because due to the time limit, I have more question about the plan and the direction in the next one. Jonathan, you're the part of ESA Space and Medicine Office, and also ESA European Astronaut Center is also working closely with METIS as well. And what kind of area of space healthcare you've tackling to solve the problem for the human space exploration recently?
I mean, everything we do is broadly separated into technology and knowledge. And technologies are the bits of hardware, the bits of software that we need to monitor, to diagnose, to treat astronauts. And we are not technology developers at the Astronaut Center. We are very much technology finders. So we rely on our partners in the different ESA member states. We rely on industry across Europe to try and find those technologies. Increasingly now in medical care, those technologies will come from terrestrial medicine. They won't be generated by the space agencies themselves. So part of my role is to go out and try and find where those technologies are. Can we adapt those technologies? Can we bring them into our program? And where we can't find those technologies, then we collaborate with the ESA Technology Directorate, and we kickstart projects to actually develop those technologies as prototypes and try and fill those technology gaps. On the knowledge side, we collaborate with ESA Life Sciences, so they are the ones who actually generate the life sciences information, and they do that in collaboration with all of the vast range of ESA scientists that exist within the ESA member states. So I think we bring the problems, we bring the questions, then we rely on our colleagues in ESA Life Sciences and the scientists in the ESA member states to help us answer those questions as well. In terms of priorities, we have kind of priorities for missions that are coming up soon and missions that will occur in the future. So for Gateway, for example, these missions are now potentially much shorter than ISS missions. So some of the very long-term problems, the chronic adaptation to microgravity, those problems will go away temporarily. Of course, they will come back for Mars missions. But for things like Gateway, we're now going to be a little bit further away from Earth. We're going to have evacuation delays, which means if we have problems, it's going to take us, we'll need new plans to manage how we manage people for 2, 3, 4, 7 days before we can bring them home. We'll also have communication delays, so it may be 4, 5, 6, 8 seconds between a message coming down to us and a message going back up. So although Gateway, for example, is not going to be an autonomous platform for human spaceflight, there are certain medical procedures, certain medical things that we may need to plan for the fact that astronauts will need to be able to take care of those things themselves. Ultrasound, I think, is a great example of this. On ISS, we provide either remote support, where an ultrasonographer on the ground actually supports people in flight, or remote commanding, where we can actually control the device from the ground. If you have real-time support, that's fantastic. If you have an 8-second time delay between messages going backwards and forwards, maybe it's not so reliable. So we don't need autonomous diagnosis of ultrasound images, but what we do need is the ability for crew members to collect high-quality images independently of us, and then we can still get those images back down to the ground for the expert support that we can still provide.
Thanks for sharing all the information. I think most of the project that you mentioned was based on Recover in Humans in Space program, and then I think through this opportunity, I think we can be more connected through our program from the next year. I think it's such a great chance to get connected, Jonathan Scott. Dr. Serena, I think we had a conversation at our booth about 30 minutes yesterday, and then we talked about how Italian Space Agency has been focusing on space healthcare in numerous projects in ISS, and especially recently AX-3 mission, the Colonel Walter Villaday, and that mission was you're leading as well, involved it. And can you share a little bit about that experiment, how it goes, and also what area you've been focusing on space healthcare project?
Yes, thank you, Jack. Yes, this year we had the opportunity with the Axiom 3 mission to have an additional spaceflight opportunity, and with this new opportunity try to both consolidate some research areas in human health, really important for us, that are really the follow-up studies of previous research that we perform in the previous missions, but also in the meantime to perform new researchers in some specific area that we like to address in the future. And for the first kind of experiment, we focus on especially on age-related disease, degenerative disease, and also disease related to muscle loss. So very important challenge issue that we need to address not only for the human spaceflight, but also for Earth. And about the new topic, the new research, we try to address some problems related to the distance from Earth and to the isolation confinement condition, which will be the problem, especially if we look at the future long-term exploration mission to Moon, to Mars. And in this context, we performed 2 experiments really interesting for identifying biomarkers, for monitoring and preventing, monitoring especially the human health in space, and in the meantime also to better understand which are the different effects induced by space environment stressors, just like microgravity and radiation, and isolation confinement conditions, which are also common to other people, other cores. So these are the main topics that we address during the Axiom 3 mission. More in general, what we are trying to do in the next future is just to reinforce our knowledge, and especially on these two last topics, so distance from Earth and isolation confinement conditions. And in fact, we published last month an announcement opportunity in biomedicine related to try to find solution to this topic, and especially we would like to support researcher studies which aim at developing autonomous system able to monitor, prevent, and protect the human health in the future mission.
Thank you very much. I think some example like Italian Space Agency work with the Axiom, and of course the Borean was being the major partner and investor in Axiom Space. We're trying to accelerate what we have done past 2.5 years, which is from this year we come up with the new investment structure called orbital launch funding, which is not only we invested for this equity stake for those startup, but also we provide them the right cost to space experiment for the entire cost up to $250,000. And I think that will accelerate those startups to be more actively having experiment in space. I think that align with that. So those are our the esteemed guests will be together supporting our humans in space also from the next year as well. And so I want to ask more about the future direction and how humans in space will be contribute, and what you guys are thinking about the space healthcare in the meantime. And Jens Jordan, I think you've been very engaged with our humans in space ecosystem already, and then how you see your the DLR's direction of the space healthcare research, and how humans in space can contribute on your studies as well.
Well, perhaps let me first get back to Jay's presentation, which was very inspiring. You know, he showed that you can, have a good idea, start with a pharmacy, and decades later, you have an international pharmaceutical company. And so when you look at what we are doing, or many of the ideas that we have for space health research, we are in some areas not even in the, let's say, family pharmacy stage. So we are at a very early stage. We have fantastic ideas, I think great opportunities for the future, but a very long way to go. And in medicine, and we are from different areas of research and development in here, but in medicine it takes a lot of time, a lot of money, a lot of effort to turn a good idea into a treatment or a new diagnostic facility. And so an important point is the start. How do you get started? Do you get access to space? Do you get, let's say, the first funding to get things starting? And I think that the Humans in Space initiative can probably help to do that and foster that.
Thank you very much. I would like to ask more questions, but we have kind of limited time. So I'll ask Audrey. We've been in partnership from the beginning, and then I think based on, we also had a partnership in terms of BSCGN Life Science Accelerator Program with the ESA, and how we should come up together to accelerate those startups from your side and also in the entire humans in space ecosystem.
Indeed, we are coordinating the Life Science Industry Accelerator for ESA, which is part of the Business in Space Growth Network, to help the space providers to find new markets in pharmacological research, biotech, cosmetic, and so on. And it's very difficult for startups from the health sector to convince that space can be useful. And this is where challenges such as the Human in Space Challenge can really help. And also, the image of Borean investing in space as well. So I think this is very interesting to help them to have a fast access to space and to ensure that they will perform high quality research with commercial space providers.
Thank you very much. Jonathan, I think you might not be familiar with, as Audrey and Jens would know about the humans in space. So like I'd explained about the orbital launch funding, kind of new investment structure for those startup and researcher. And those type of investment, how do you see affect your current studies and also EAC on the space healthcare project in the meantime?
Yeah, I mean, one of the nice things or the difficult things about human spaceflight is it affects so many physiological systems and so many processes that you have a million different questions to try and answer. And right now, we don't have a million different ways of getting things into orbit to answer those questions. So any mechanism, particularly humans in space mechanism, that makes low Earth orbit more accessible, particularly highlights it to emerging and smaller companies. As I mentioned earlier, we're increasingly relying on medical technology from terrestrial companies to supplement what we do. So if those companies can be made aware of those opportunities, if there can be more opportunities to get these technologies into the microgravity environment and to test them, then it will really give a significant boost, I think, to our ability to detect which technologies are really going to work, which ones may not be the ones to chase, and then to focus our attention on the ones that really work as well. Very quickly on human studies, if you've ever been to a life sciences conference, the question you always get asked is, why haven't you got more subjects in your study? So any system that allows us to collect more data more quickly from astronauts is a huge benefit as well, and we can really answer these questions more quickly and figure out where the new knowledge gaps are based on those data that we collect.
Thank you very much. Serena, so we had a big conversation at the booth, and then please share about the entire direction of the space healthcare under your Italian Space Agency in the future, and then also about how humans in space ecosystem can contribute also Italian Space Agency agent the space healthcare study together.
Yes, as I told before, in the future, the idea is just to reinforce some research areas of the human space flight and to support additional and different research areas. And we think that the ecosystem, the national ecosystem in terms of companies and also in university research institute, we should contribute for a better understanding of and find also solution and possible countermeasure for in the new research area that we would like to address. So.
All right, thank you very much. I would love to have more discussion with our guests, but I think the time's already passed. So please, if you have any question to come to ask to our guest. And like I explained earlier, the Humans in Space was the first presence in IAC, and then we will be in IAC in Sydney next year as well. So please stay tuned, and please enjoy the rest of IAC. Thank you very much.
Where's the... Hello, everyone. Hello. Welcome to our session on the heads of think tanks. It would be great if we could close the doors, please. Thank you. Thank you very much, everybody. And I'm really delighted to be here, and I'm delighted to have you all here with us. It's going to be a very interesting panel. I'd like to introduce our panelists today. We have at the far end, we have Hebe Romero Talavera, who's a member of the Aerospace Research Center of Paraguay. We have beside her Hermann Ludwig Müller, Director of the European Space Policy Institute. Then Jamie Morin, Executive Director of the Center for the Space Policy and Strategy Unit at the Aerospace Corporation in the US. And finally, we have Ikuko Kuriyama, Visiting Researcher for the Institute for Future Initiatives. So I'm really pleased to be here because I think we have an opportunity to hear some fascinating thoughts. They're all think tanks. Their job is to think outside the box. Oh, sorry. Oh, sorry. Yeah, thank you. Thank you. Their job is to think outside the box, to propose, to challenge established thinking, the status quo, and to shine a light on future possibilities. But before we go into this session looking at the future, I think it would be helpful to the audience, certainly to me, to understand a little bit about the different regional approaches to space and the future of space. So I'll just sit down now and come over, and I'd like to start. I'll start with you, Ikuko-san. If you could just tell us a little bit your perspective, what is the approach to the future of space and space sustainability in the Asia-Pacific region, but more specifically Japan?
Hello, everyone. My name is Iko Kuriyama. Those who you don't know about my institution, it's a think tank under the University of Tokyo for visioning the future and the policy recommendation for the issues on the social issues in the future. And so I also thank SPN Space Policy and Strategy to invite me in this wonderful panel. So moving back to the questions. Thank you, Peggy. So yes, I think the perspective, approach to the space sustainability in Asia-Pacific region, but here I'd like to a little bit focus on this Japan, if you allow me. And I think we take a broader approach to the space sustainability. So in fact, the Japanese space basic policy said they are addressing resilience and also global issues is one of the pillars of our space policy objectives. So, and also we pioneers to launch the CO2 emission monitoring satellites called GOZAD back in 2008. So it's space sustainability is not just space debris for us, but today I would like to a little bit focus on the recent and forward-looking tendency in Japan. So when I talking about space sustainability and in the recent trend in Japan, what the key word for me is the taking advantage of the first move. This is, I think, I would say this is the Japan's strategy towards space sustainability. And so in the past, we tend to make an effort to, much effort to technological development, but not as much as for the setting rules and norms. But now we Japan is trying to lead the discussion, international discussion on international rule making on space sustainability. And what makes this position in my view, is there are, I think, 3 points: and technology and policy and real use case for applying the technology. And I'm going to explain a little bit more in a concrete way. You know, maybe you know that there is a company called Astroscale, very famous now, and it's a visionary company. The company is aiming to address space debris issues as a commercial endeavor. And we are lucky enough to have such a visionary company in Japan. So now Astroscale is trying to, I would say, in the front line or in demonstrating their technologies, new technologies for ADR mission, active debris removal, and JAXA, a partnership with Astroscale, for supporting their R&D and also our funding. And Japanese government also take a central role to promote establishing the institutional environment by authorizing and issuing the license, and also, more importantly, issuing guidelines on on-orbit servicing. So, therefore, three these things: technology, policy, and use case of the real use case of the technological application is, I think, these are very important for advancing international rule making, and in Japan is now in the good position to advancing responsible behavior in outer space. And this was really backed by the concrete policy. And so, and next, we are now going on issuing another guidelines. So please keep an eye on Japan's activities. So we we are going on and these activities and in the front line. Thank you.
Thank you very much, Ikuka-san. It's very interesting. Japan wants to take the lead in international rulemaking. It's about a coherence between making the rules and also feeding it through the ecosystem. Jamie, I'd be curious in the United States. I mean, the United States takes the lead in so many areas as well. But when it comes to things like, if you want to talk about space debris, maybe it's moving very fast, but maybe a little bit later than others, if my understanding is correctly. But then also it has been very much in the lead in other areas of trying to create a sustainable space. How do you see it?
Yeah, I guess I would start with one overarching point, which is for U.S. thinkers on issues related to space sustainability, I think there's a strong thread of thinking about it in terms of the future benefits of space, right? So we're taking advantage of space, in particular now low Earth orbit, for a whole bunch of activity which is relevant for the lives and livelihoods of people on Earth. Certainly the exploration activity is inspiring and important, but the issues that are raising challenges for space sustainability now are primarily due to effort to create value on Earth, whether it's environmental monitoring or communications or what have you. So we should be looking at topics of space sustainability with an eye to sustaining the benefit that humanity gains from activity in space, primarily. So that's an overarching thread. There are a number of key areas, and I won't be able to mention them all, in which U.S. national leadership and others are deeply engaged on space sustainability. I'll hit just two quickly. One is space traffic coordination, right? We are entering into a world where we have order of magnitude more satellites on orbit than we had even just a decade ago. And we are on a growth path that is likely to continue for several years. We've actually done, I think, reasonably well over the last 5 years in grappling with this growth. It's been managed reasonably well, but that has occurred, in my mind at least, largely because much of the growth has been within a single company, who has, of course, all the economic incentives to not run into themselves. It is about to get much more difficult We're going to have multiple companies operating with thousands of satellites from multiple countries, some of whom geopolitically struggle with communication. So moving forward on approaches of space traffic coordination is a key line of effort that has been underway in the US, I think, for probably about 5 to 6 years now. We recently had the chance at the Center for Space Policy and Strategy at Aerospace to host an event that brought together the European Union Space Surveillance and Tracking Team and the US Department of Commerce's team working on space traffic coordination issues. We have those exchanges regularly, and those, I think, help because it is a global effort. The final point I wanted to raise is that NASA, which for decades has done seminal research on orbital debris, on risks of reentry, on safe operation of satellites, they earlier this year, released a space sustainability strategy document. And I thought it was really remarkable, in part for an agency that has been leading in these areas for a generation or more. There was a strong element of humility in there. And it was essentially said, there is a lot where we struggle to make progress on space sustainability because we lack common frameworks, common set of definitions of terms, common set of understanding of what we're trying to maximize. And so they laid out a need to build to that framework on a global level. And they laid out a need for a significant amount of additional research on issues that get wrapped into topics like carrying capacity and the like, where we don't understand well enough some of the critical variables. So it's a good strategy. It's worth looking at for folks that are interested in the topic. And I thought it was particularly remarkable in that it really did lay out the knowledge gaps and the common understanding gaps that stand in the way of long-term progress here that have to be addressed.
And frankly, and I think that's hugely important, it's one of the things that strikes me that, that humility to admit that, we don't know, we're behind, there are areas, that offers the opportunity for global discussion, actually, because there's no geopolitical advantage in a research paper that says this is objectively the problem that we have in maintaining a sustainable space. So that's very interesting. Can I move on to Ludwig then in Europe? I mean, Europe has been talking about this for a very long time. How do we get a sustainable and secure space for a sustainable and secure planet? What is your view about how Europe is looking at this? How is it approaching this question?
Yeah, I guess I'll resonate with Jamie first. You started with the benefits. So it's about Earth. This is why you go to space in many instances. So when we say sustainability, this is about making sure that space is safe, but it's also making sure that space is used for sustainability on Earth. And this is, I think, what Jamie talked about. And those includes things like being able to live with +2 or +3 degrees in the future to come. Yeah, this is about sustainability of our lives and where space can help. Now, you know that we are in an audience here in a conference where I assume that people are familiar with a few things when it comes to debris and the classical term of sustainability, how it is often used. But the point I try to make, it's really sustainability in space, it's sustainability from space already. Now, to answer your question, really, when it comes to what do we do about the in-space part, Europe is Europe, so you have nations, you have ESA, you have the European Union, you mentioned the EU SST, we work with the EU SST's space traffic management, rules of the roads, distances to respect. I think those are some of the ingredients of what is up for debate. When we talk ESA, there is an effort to work on a bigger community, so not just the ESA missions and what ESA can do about it, but really work on building an ecosystem of others and work in a federated effort. And there is an accelerated, it's called PROTECT. That is something we are supporting. And when it comes to our host country, based in Austria and Vienna, and in the national strategy, there is a particular emphasis on sustainability, and that includes also for Earth. And early next year, we will launch a center of expertise for space and sustainability. And this will be things like smart cities and the like energy transition. So all this is happening, and we work across the European system. In fact, we work also across the Atlantic. So the meeting you mentioned, we were in, it was Colorado Springs, there was a session, in fact, when this was discussed. I know that the EU SST is very prominent on this. So I think many actors, and the main message I want to give is, A, there can be, obviously more needs to be done. We maybe come to finance in the discussion. It's about money also to be able to do things. But also let's make sure we put forward the benefit and why, in fact, we do this. Why would we clean up an orbit? What do you need it for? So it's really the duality of this that I would really like to, all of us here, to be aware, and when we communicate about it, to remember.
Thank you very much. And Hebe, from Paraguay and from the perspective of Latin America, what is the sort of approach there to thinking about space and the sustainability of space, the benefits?
Thank you, Peggy. Good afternoon, everybody. I would like to thank to the European Space Policy Institute, and especially for Alberto. Okay, respect the questions, especially in Paraguay. We are trying to promote a better knowledge about the space. This will lead to a better environmental protection. We are promoting university research in this area. This is important it's a first step about the perspective of the sustainability. The first is knowledge.
Brilliant. Thank you. Thank you very much. So, yeah, I mean, that is always the first step, isn't it? Making sure that people actually understand both the opportunities and the challenges. So a few of you have mentioned opportunities, the benefits to humanity. So I want to dig a little bit more into, we don't talk about space, as Ludwig's just said, for space's sake. Yeah, it's cool, but actually it's got to do something. It's got to add to the economy. So I'd like to dig in a little bit about the link between sustainability of space and the economic opportunities and how those are perceived, how you think tanks yourselves are looking at the opportunities and pull out whether there are different perspectives on these opportunities. I'll come back to you, Ikuko. Can you just tell me how, again, you've talked a bit about Japan wanting to lead in international rulemaking, you've talked about astroscale, but let's talk about the opportunities. Why does this matter to Japan? Why does, why does sustainability matter from an economic perspective? What is the opportunity that Japan actually sees?
Thank you for the question. Opportunities. Maybe if I use the case as astroscale, I think it's because setting a rule can be how to say if maybe I will not say in a different way. So making opportunities because making this sorry, my point is to not sustainability or look as a burden or cost, but making this sustainability as opportunities for cooperation and opportunities for economy and opportunities for partnerships and innovation. So, well, when I use the case of the astroscale, as I mentioned, so we JAXA are partnership with them. So it's opportunities for partnerships and also it's a new technology. So it's also opportunities for technology, innovation, and also opportunities for making a new market, if possible. If still Japan doing this, I mean, because for the astroscale, everyone, it is often said that nobody pay for space debris removal, but if But now, so as I mentioned that project together with the JAXA and Astroscale, it's called CRDS, then we ask actually the Astroscale to remove our space object. It's actually the second stage of our launchers. Then, so we pay for that. And then let's think about how to remove that. Then if this is still our JAX only Japan, but if if someone think that this is really nice and we can follow that direction, then another guy doing this situation, then we can create market. So we can see that this opportunity is setting a rule and also setting a de facto standard, and in the end we can create new market. This is a opportunity, I think, for
create new markets. Ludwig, let me come to you then. You know, in terms of the opportunities that space is going to create down here on Earth. So we've heard about creating a new market. How are you thinking when you look at the regions across the piece? Where are the opportunities? What's the important thing to be thinking about?
Yes, you asked for regional differences, and I would maybe start by saying that sometimes in Europe there's a certain preference to regulate more than to take the opportunity to develop what you just elaborated. In fact, Astroscale started on a European project in a PPP, public-private, and today it's in Japan. We do this. There are discussions now on EU level, also Germany, so this is happening. And I'm not going to in the details of this. They're only saying that we need to be careful when we do this, that we do not put up an obstacle for the opportunity, which is at least on two levels. It's an opportunity, you said, creating new markets. So this could be an active debris removal company that makes business. But this is still within the perimeter of the market opportunity of that particular type of job you do for sustainability in orbit. But maybe more importantly, it is really what this orbit, once you have a clean orbit, safe orbits, what you can actually obtain from it. And if you look into the space economy, you could say, well, there are numbers around. You may know some of these numbers. People talk about a 1 trillion economy in 2040, and there's a lot of dispute about it. This is still the economy for the space companies, primarily. Now, it almost misses the point, because what you are after is really to penetrate into other sectors. So that can be agriculture, that can be pharmaceutical, it can be transport, it can be energy transition, it can be pretty much all disciplines, it can be internet, it can be part of digital. And if you look into this, then you get to another multiplier effect. And I think a lot of the discourse, when you talk about space, or Quo Vadis space, and I just consider sustainability as a prerequisite for it, I think this is a part of the discourse that we need to animate. And this is maybe not enough in the debate. Yeah. So to summarize, it is an opportunity for space industry that will put up businesses that did not exist, and Astroscale is a perfect case, and this will happen. It will still be a smaller part of the space economy. It will help the whole of the space economy also to exist, and maybe not to not exist anymore tomorrow because we have a problem in space. But more importantly, you get a multiplier. If you take other transversal technologies, semiconductors and the like, and you can compare space to these transversal technologies, you get multipliers from, let me be careful, between say 3, 4 and 5, 6 or 7, and that is big numbers. Yeah, and this is what we really want to obtain from space. And when we say Quo Vadis space, I think this is a big heading. And if you make this heading clear, then also the argumentation why you need sustainability, you need investments, we will come back to that again, to really do something about it. Japan does it with Astroscale. Others maybe, and talking about Europe, do not do it enough yet.
Thank you, Ludwig. I wonder, Jamie, is part of the problem here that we think about space being cool and space on its own, and we don't think about space, almost as Ludwig's talking about, when we're thinking about the opportunities as an enabler. You think about the railroads, or you think about the roads. In and of themselves, a bit of tarmac is not interesting, but the capabilities that it opens are just incredible. So is there a problem here? Do we need to start talking about space differently in order to make people understand the opportunities?
So it's a terrific question, and I actually, early in my career, worked as an economist, and I think one of the most powerful concepts from economics is the notion of the externality, that there exist certain activities that produce unpriced costs or that have unpriced benefits, and that those create imbalances, right, or opportunities for less than socially optimal outcomes from markets. Clearly, pollution is one of the classic negative externalities, whether in space or otherwise. We have, up until recently, really not acknowledged those negative externalities from space activities. We also, as you've just said, often understate the positive externalities that emerge from space activities. We may talk about, technological spin-offs or what have you, but particularly in this, with this move to ubiquitous space communication, and in the face of the climate crisis, the need for extremely timely monitoring of weather for mitigation of effects, and potentially in a future where we have some sort of international agreement on emissions that has binding terms to it, maybe even verification of compliance with it. Those are areas where space can produce enormous positive externalities for society as a whole. And so we have to continually assess and talk about the value of space. But we also, I think, have to challenge ourselves continually to do better. And a number of economic concepts are helpful for us there as well. My colleague Karen Jones at Aerospace did a really good set of research over the last several years on moving toward circular space economy, and argued for life cycle estimates on the environmental costs and benefits of space activity. And I think there's a great deal to be said for that. We need to think in longer terms, and we need to be thinking about how can we maximally reuse and benefit from the things we've already done. By the way, these things get even more significant the further away from Earth you get. Not because the orbits are larger, of course, but if you move to the cislunar domain, right, the cost of moving mass there is extraordinarily high. So the incentive to figure out ways to maximize what you have there is even higher. And all of our traditional ways of throwing away our trash in low Earth orbit, they don't work, right? There's no atmosphere to burn your satellite up in. So we really do have to become much more serious in thinking about these issues and much more future-oriented, because we're making decisions with generational consequences.
Ikuko, you're nodding away. Is there a point you wanted to make as well? You're agreeing. Has it sparked you with a thought that you want to share with us about how Japan thinks about this?
Well, I don't know it's Japan's whole approach, but I really agree with Jamie about the life cycle assessment is needed. If we, solve the debris issue, then if cause another problem, then it's nothing. So we need to integrate, and we need to take holistic approach to this issue, I think. This is my personal view, but I really agree with what you say, Jeremy.
Thank you for that. I'd like to come to Hebe, because I think just from our discussions before, as far as Paraguay is concerned, you see that when we're talking about the opportunities, Paraguay sees this as an opportunity both for technology and jobs. Am I right?
About opportunities, I think the space sustainability opens opportunities in areas such as engineering, research, telecommunications, cybersecurity, and environmental management. As more space projects developed in both the public and private sectors, there will be a growing demand for specialized jobs, labor. This could motivate the creation of educational programs and technical training in universities and institutions across the region, leading to highly skilled jobs and fortified local capabilities to participate in the global space industry is my point of view.
Thank you very much, Hebe. So there's wonderful opportunities. We need to think more about these opportunities, the sort of negative and positive externalities as you're describing them, and that kind of, as Ludwig says, that kind of almost exponential fallout, the kind of ripple effect of space down here on Earth. But one question I have, if what we're saying is we start from we need a safe and secure environment in which to operate, up there, and in which to have dynamic technological, economic expansion, whether it be for Paraguay, Japan, the US, or Europe. But actually, one of my questions is, in a way, well, let me say this. I was talking to a couple of Chinese companies this morning, and these Chinese companies were saying to me, we have some of the strictest rules. We need propulsion on every aspect of a satellite, of a rocket, of everything. We have to actually, even on a CubeSat, he said to me, a CubeSat has to have propulsion so that we can actively deorbit it. And then he said to me, and that makes us uncompetitive. So what is the link between sustainability and competitiveness? Can sustainability be used as an anti-competitive tool by other countries, or even can it place a burden on your own industry? Jamie.
Yeah, so look, this is a terrific question, and let me use the example of Paraguay here. The first satellite launched out of Paraguay involved a collaborative effort between university and government there, and JAXA and NASA, and was launched out of the International Space Station. It was a small CubeSat. I don't believe it had propulsion on it. It's also the case that a small CubeSat launched from the International Space Station will re-enter within a year or two of being pushed out. So it's not a major risk to the sustainability of the space environment. This, I think, argues for a tiered approach. If I am planning to launch 10,000 satellites to conduct business activities in orbit, I think it makes a great deal of sense that I should be subject to significant scrutiny for the effects of those systems on sustainability and other considerations. That doesn't mean we need a one-size-fits-all approach where Paraguay's first satellite, or a satellite being launched by a university class that is a CubeSat that will only last a year or two on orbit, needs to meet all of those same standards. The benefit to the long-term sustainability of the environment is very different. So I think 2, 3, 4 tiers probably make sense, where the things that are being done at vast scale need to be looked at for all of the impacts. What's the impact of it burning up back in the atmosphere? What's the impact of its end-to-end production? All of those things ought to be looked at. But we don't need to do that for everyone, because if we did do that for the new entrants, we would essentially lock in the current participants. And that's, while that may be helpful for individual business interests, that's unlikely to be helpful for the long-term dynamism of space research or the space economy.
And also back down here on Earth, if that's what we're talking about.
Exactly.
Yeah.
And we have reasonable considerations about equity as well.
Brilliant. Thank you, Jamie. Ludwig, you looked like you were bursting to say something.
No, I wouldn't. No, it's obviously a big question. The short answer would be most people will say, yes, this is a burden. People that build a satellite, they have a cost. It's an extra cost, sure. And if they're the only ones to get that as a requirement, they will complain that they are handicapped in a global competition. That is very unromantic and true. So this is one aspect to look at it. Then you could probably assume that somebody like Starlink, they probably have an interest themselves not to screw up the system. So it's a big operator, many satellites, they will have a rule set that makes sure this thing doesn't fall off the skies. So there is a bit of an auto-regulation also in it. Will this be enough if you populate with multiples of these in the future? Maybe not. Maybe the return on invest from a total business case, which has, I mean, that's a number of years, and you cash in on a system, and in fact, it could crash at the end and your business case closes still. So I wouldn't rely on this completely. Yeah. So there is an element of de-risking that people will do, and there will be best practices. I think this will exist. It's necessary. It's also good to get this going and get best practices, because a rule set to establish and a law from the skies will not happen so quickly. So you need reality and best practices, and I think what, again, Astroscale is doing on active debris removal is another example. This will happen, and it will set, I think you said, de facto standards, so things are happening and shaping. Now, but the real question is, what do you need to do to protect the economy? It's not only the return on invest of a company, it is really the economic benefit, social economic benefit. That's a different way of looking at it. And this is where this whole debate comes into play, and we have a true requirement, I would think, to put things into frameworks that you can only launch things if you comply with certain requirements. And then you have to make sure that this is applied to the maximum extent possible across the oceans in different world regions, so nobody is feeling handicapped. Well, ultimately, this is a need, because otherwise there will be a limit of what the system can take as a risk.
Absolutely, and it leads very nicely to a question I wanted to put to Hebe. As as Paraguay, we have Europe, we have the US here, we have Japan, very big space powers, and Paraguay, an emerging country in space. What do you see as the barriers to accessing some of this technology for Paraguay? Are there problems in accessing, in benefiting and exploiting space and a sustainable space?
The contribution. I think the space sustainability could both the development of new technological industries in Latin America, such as small satellites, manufacturing, environmental monitoring, and remote sensing. These sectors have the potential to generate employment and open up opportunities for the export of space technology and services. Space technologies can improve sectors such as agriculture and management, which could positively impact local economies. Nice.
Thank you. I think one of the questions, we're talking a lot about, the kind of global approach to a secure space so that we can benefit down here on Earth. But the big elephant in the room has to be how can we encourage and involve countries like China and Russia and work on this together so that it's open and available for everybody to benefit. I mean, Jamie, what's your view on that?
So it's an incredibly important issue. I regularly hear from people involved in space situational awareness, tracking of objects in space, that, including satellite constellation operators, that they struggle, particularly when they have conjunctions between their spacecraft and Chinese spacecraft, that getting communications with the operator is not consistent. And so that is a problem now. That will be an increasing problem as the environment gets more crowded, and particularly if we see similar issues with Chinese constellations numbering in the thousands. They're already a very large operator, of course, and a skilled operator. So, I mean, we know they have the capability to address this. It's a matter of understanding how we can communicate internationally in a reliable way. There are technical challenges to be addressed here, particularly with regard to object tracking and sharing data in ways that is making more sense, not creating more confusion. It's not a trivial matter. With regard to Russia, you know, this is a difficult time. And I guess I can't speak on this issue on a topic of space sustainability without a mention of the geopolitical and massive overhanging risk, which is there's apparently, you know, clear evidence that the Russians are looking at putting a nuclear weapon in orbit. So you talk about sustaining the space environment, that does not fit. Yeah. That does not fit. And so that's a massive risk to the entire space sector. And I guess that's a gorilla in the room that has to be addressed on any topic of space sustainability.
And I suppose what we want from think tanks are thoughts about how we can address that. Ikuko-san, you were nodding away earlier as well. I take everybody's nod as a sign they want to say something, so you know I should just warn you. But Ikuko-san, you had some views on this, I think.
Well, thank you very much. Yeah. So, yeah, I really agree that we need to engage China and Russia in the international discussion. And yes, maybe you saw me as a very idealistic, but as you know, the future summit UN Summit of Future adopted the Pact for Future, if I remember that. So United Nations member states, I think including China, agreed to discuss the governance and the international framework on STM debris, space debris, and space resources. So now we have a commitment or a foundation to engage China in international discussion, and because it's through UN and through using a corpus as a venue. So I think they still participate in the UN, and a lot, I think. They wanted to discuss this issue. And if we can agree some goal, or we can share the goal, even we don't take different same approach, I think we can work together. As you know, for Paris Agreement, you know, with SDGs, it's miracle that all UN members agree and share the same goal. But we can take a different approach to implement that goal. And this, I think, is a very new model to implement the shared approach, and then every state can take their, declare their commitment by themselves and to raise ambition to reach the goal. And if this innovative governance system is applied to the same debris issues and other things, maybe China and Russia can participate in this.
You're quite right.
Yes.
It's quite right to remember that Pact for the Future. It was very important. And Ludwig, very quickly, do you have a view on this at all?
Yeah, first, thank you for the gorilla. I thought it was an elephant in the room normally.
Did I say gorilla?
Or a bear.
Oh,
He's
Jamie.
a bear.
Jamie. Okay.
That's the US version. So we talk about the elephant in the room. And let me start by saying there are probably two elephants in the room, or gorillas. We talk about Russia or China people. Probably I would make a distinction between the two.
Yeah.
I think China is investing heavily in space. They may have an interest not to screw it up. Russia may be a different case. But the point I try to make is the other gorilla is really, you could have a rough, not a state, but you could have a rough company that goes to some country and gets the license to kill, sets up a business case of like 3 years of lifetime of a big thing and exploits it and doesn't care about the garbage. That could also exist.
Yeah.
And I think we always look in this on a per country basis or particular countries. I think this is part of it. And And if you look at this as like an onion, in the center is the industry, single industry is Starlink, and I said they make sure that they are safe, let's say.
Yeah.
Around it, you have other industries, and they may adapt something of what Starlink is doing, and maybe there is an incentive to do it in the two directions. Around this, you may have like-minded countries that support these industries, and they try to come to best practices, as Japan may be doing with the Astroscale. And around this, it's getting complicated as soon as you go beyond the like-minded, and there is no real solution. I do not think that a debate in the UN will solve this anytime soon. What is the consequence? The consequence is you still need to do your job. I think we need to do our job with the industries, give them the opportunity, but maybe also some obligations, and work as much as we can with the like-minded. And you mentioned what we did earlier this year in the States. Let's do that job and then see that we create an element that maybe is part of a global solution. But what we cannot do is wait for the universal solution. That will not happen.
And on that note, because we've now run out of time, and I'm so sorry, there were so many other questions I wanted to ask, I think that's very important to remember. We shouldn't be waiting around for the perfect, but we should be working on what we can do to improve the imperfect. So on that note, I'd like to thank the panel for a really interesting discussion. Thank you so much, everybody, and thank you to the audience.
Hello? All right, who's ready to talk some space law and policy, huh? Space law and policy. Highlight of the IAC. This is what we've all been waiting for. So, thank you so much for coming, for achieving unified global governance for civil space exploration. A couple of weeks back, I was doing an interview on News Nation, national news, and my interview got delayed, so I actually had to watch the news, which was appalling. It was just 20 minutes of war, hurricane, destruction, more war. And I was so glad when they got to me, and I told the host, now we can finally see some good news, right? Now I can talk about something good with space development. And that's truly what we are in the space sector, that this is the good news that the world needs. And in terms of space law and policy, I think we have a singular opportunity to weave a diverse group together to make sure that when we move forward with better technology and better space exploration, we're also moving into a better world of more peace, more working together, more collaboration internationally. And that's what we're here to talk about at the forum. And we have a blockbuster lineup of just some fantastic, these are the stars in the heavens here. This is the Beatles of space law and policy you have right here, let me tell you. So it's fantastic to have this panel. One of us has to catch a plane, so forgive us for that, but we're going to let Frederick go first because of that. So let me introduce, with no further ado, Frederick Nordland, currently the head of External Relations Department at the ESA Directorate of Strategy, Legal, and External Matters. His functions encompass, among others, the provision of support to the Director General of ESA, the Directorate of Strategy, Legal, and External Matters regarding the relations of the agency with international partners, the formulation of the agency's position on international developments, and the negotiation of cooperation agreements, meeting demands, the ESA programs and activities approved by member states. Let me tell you, if it wasn't for this man, I don't think we'd have a Gateway. I don't think we'd have an Artemis program. So let's have a warm round of applause for Frederick Nordland.
Thank you. Is that working?
And so, Frederick, the first question that we've got coming over to you, assuming I actually have questions, is what role do you see ESA playing, European Space Agency, in supporting the development of norms of behavior in space? And why do you think norms of behavior are important for space development and exploration?
Mike, thank you. Can you hear me? Yeah, okay, that works. God, first I will have to tell family tonight that I was on a panel and I was part of the Beatles. I mean, that's it's going to be that's quite something.
Which Beatle are you?
John.
John, there we go.
I think this is going to be a fun governance panel, but okay, we'll see. First of all, it's an honor to be with you on this panel, really, and a real pleasure. What can we do? And I represent a space agency on this panel. So what can we do as a space agency? We're not a normative organization. So we're not a regulatory body. So what we can do is actually maybe by our own example, show an example, and we don't claim to be any better than anybody around the world. That's not at all what I'm saying. But what we can do, for example, is meet RT in Vienna and publish a document to explain how we register space objects with a digital platform which is completely transparent and for everybody to see. Or if we go for zero debris, we have internal instructions to start having ESA as an actual real zero debris agency by 2030. So we issued already an internal instruction for all ESA future missions to meet that goal. It's a very tough one. But what we do by this is we explain to the international space community how we intend to do it, how we're starting to do it, actually, and implement this. And so what we do is that every future missions to be approved by the member states will have to meet all these technical requirements. And we will revise these requirements for being a zero debris agency in 2026, in 2027, 2028. By 2030, we have to be there. We are crazy enough actually to launch by 2027 a small washing machine, small satellite to LEO, to low Earth orbit, to have that satellite destroyed
we wreck it. It's kind of strange for an agency, to do that. Why are we doing that? It's because in that satellite, we have 200 sensors that will tell us about re-entry, behavior of re-entry, and how we can derive that information to share it with everybody in order to meet the 5-year re-entry requirement to be in the future, cleaner and neo. And these are the type of things through technology and own commitments where we believe at ESA we can influence the international space community. But once again, we're no better than anybody on this. We're just showing one example. There could be better examples, and we would be very happy actually to learn from these better examples. But since we're not engaged into any formal normative actions, we want to use every single international forum to actually do exactly this. So the UN COPIOS is, for example, one where we published a number of years ago, and we're updating these papers to show the rest of the community how we implement the long-term sustainability guidelines. And we're very serious about this. And so, again, no better than anybody, but this is the way we're doing it. And there is really a strong conviction at ESA by the Director General and all of us that by being transparent and showing a lead-by-example approach, we could eventually influence the international space community.
Wonderful. Thank you so much, Frederick. Next, we are going to turn to the director of the UN Office for Outer Space Affairs, who took up the post on September 18th following her appointment by the UN Secretary General. She brings over 25 years of experience in the space and satellite sector, working predominantly with international organizations and regulators. Prior to her appointment at the UN, she held the post of Secretary General of the Global Satellite Operators Association. And let me tell you, Artie has brought an incredible energy and dynamism to this post that has been something that I really thought INUSA and the UN and the space community so desperately needed. So we're very, very grateful for that. Question for you, Artie, is maybe you could give us, and I can't imagine anyone isn't familiar with INUSA, but maybe just a little bit about what INUSA is, what it does, why norms of behavior are important, and the role that norms behavior play for INUSA. But before that, which beetle are you, Artie?
I'm the beetle called Fred.
Ah.
I'm just, there was no woman beetle, for God's sake. So, what can I say? But I was just picking on him. Because if you're John, I'm Fred, then maybe. Well, whatever.
I'm going to end up getting Ringo in the end, by the way. I'm sure Goyo's still got Paul available.
Yeah.
So, no, but thank you, Artie.
Thank you. Great to be here. COPUOS has the history. It is the birthplace of all of the space treaties and guidelines and principles and resolutions that underpin the space economy as we know it today. It's always criticized for being too slow and too long, and everything it's done is out of date and old and not fit for purpose. Not true. Not true. We have a line of 60 countries waiting for our technical assistance missions to implement space law. And those space laws have as their cornerstone the implementation of the principles of the Outer Space Treaty. So it is as relevant today as it was in 1967 when it was made. But it also has a track record. I mean, COPUOS has really kept up as best it can with the needs of the moment. The latest product being the long-term sustainability guidelines adopted by consensus in 2019. The issue is that we need them to be implemented. So I know that you have a separate question on challenges, so we won't go there as yet. But you asked, what does UNUSA do? What is our role with respect to that? I see the role of USA being increasingly important. We were set up as an expert unit back in 1957, before probably almost everyone in the room was born. It was set up as just a secretariat. That means, producing the agenda, inviting people, and so on. Not really a big role. Meanwhile, space is so important, and with that, our role has grown. We also have a capacity building role. And I see that not just in terms of helping member states access space data and solutions to achieve the SDGs and achieve their national objectives, but also very much when it comes to space governance. We see in COPUOS such a diversity in the level of knowledge of the delegates. You will have experts who come from space agencies, some will be space sustainability experts, but you will also have just attachés from the permanent missions. But each one is at the same level in terms of being a decision maker in the committee. So our role is really to make sure that we level the playing field in terms of what they know and understand about different elements of space governance, be it space traffic management or space debris. Many delegates have never heard of ephemeris data. Many of them have no idea what is a conjunction warning. What happens when an operator receives a conjunction warning? What does he do with it? Does he call someone? Does he panic? Does he press a red button, or does he speak to other operators? No, people don't necessarily know. So as we go forward, whether it's space traffic management, whether it's on-orbit servicing, whether it's lunar coordination, I see the role of the office really increasing to make sure that the delegates have a solid understanding of these topics, because we invite them to take decisions on topics which are necessarily complex and technical.
Fantastic. Next up, we've got Guoyo Wang, a doctoral degree in law and economics. He is the dean of the Academy of Airspace Policy and Law at the Beijing Institute of Technology, which is not actually the Space Policy Law Beijing Future Space, which sounds awesome, right? Like we'd all like to do that, but isn't actually true. He's been legal counselor in space law, CNSA, Lunar Exploration Center, board of director in ISL, board of member of the advisory committee for SWF, council member of Global Future Council, etc. Guoyo and I first met at the Hague International Space Resources Governance Working Group, the name rolls off the tongue, where we collaborated on safety zones back in the day, which actually found its way into the Artemis Accords from that initial work. Everyone, let's have a warm round of applause for the Paul McCartney of Chinese space law, Guoyo Wang. Guoyo.
Thank you so much. Thank you, Mac, for that. So, but I apologize about my voices. Maybe not suitable to do the Beatles things, but a little bit rock and roll sense there. Thank you so much. Talking about the Hague Working Group, of course, I did learn a lot from you and our colleagues there. So always I can learn a lot from discussions, no matter. In Vienna, Geneva, I mean UN framework, or other platform beyond UN. But to be honest, I have to say the discussions beyond UN sometimes, I mean, it could be more open. It's no wonder, right? And also could go deeper. So that's my personal feeling there. The role of the NGO. Or the academic institution, in this case, I mean, is sort of irreplaceable, or say indispensable in the process of the formulation of the international regime for, say, space exploration, not only just civil, but also security activities there. So, as to me, I think that the discussion led by NGO or the framework beyond UN, actually it's just serve for the discussion in UN. And it could provide the very good basis. The reason I'm thinking about it, because I think the four main characteristics that, for the NGO or academia, I mean, they are more capable of, carry on such kind of characteristics than the governments, say like forward-looking, deep going, comprehensiveness, continuousness, you know what I mean, right? So, like, it's not like security domain, it's a little bit different. Where, states might be more aware what they want. They have more information than NGO academia about how to achieve strategic priority, strategic balance, in the security, or we say the military domain. Even so, governments sometimes are just short-sighted and still needs strong intellectual support from think tanks, from academia. But I have to say the threshold a little bit high, in the security domain for NGO, particularly for, for industry, The threshold is a little bit high. Not like a civil domain. I mean, if a NGO just focus on one matter for years, keeps working on it, so always it would have some valuable things at the end, just like the Hague Working Group. You see, it provided the concept of, you mentioned the safety zone, priority rights over the prospected or abstracted resources. These concepts has been discussed almost 10 years. And of course, provided a very good basis, valuable references for the possible discussion in COPUOS. However, these such kind of detailed issues have not been discussed yet in COPUOS. So that's again, my personal feeling there. NGO academia is more capable of following such kind of characteristics, as I said, which are the inherent requirements to formulate international regime for space governance. No matter it's about space resources exploitation, it's about space traffic management or coordination, it's about much constellation management anyway, they are the same. So the last point is that another reason about the continuous things, a scholar can focus on one domain for decades, like myself, but it's not the case for diplomats. We know the practices in many countries, in China, right? 3 or 4 years, people just changed. But the historical experiences just shows it always takes longer time to draft a treaty, or even just the non-legally binding document. Say 8 years. That's my personal experiences in the LTS guideline, 8 years, and say almost 12 years for the nuclear power sources, the resolution. So that's why I argue that the role of NGO academia is so important.
It's such a great point that you make, Guoyo, because diplomacy is not moving at the speed of technology. That, when we started talking about safety zones and that sort of thing, when you and I were back in high school, now these are not academic issues, that we've got CLPS landers occurring. We had China land, we've had Chandrayaan land, that we are having activities on the moon and we're racing to catch up in space law and diplomacy. And absolutely hear you that the NGOs are important, particularly because there's no seat for the private sector in many of our institutions, domestic and international, although Artie's certainly working on that. Certainly we can't have a conversation about norms behavior without talking about the Artemis Accords and ILRS. I'd like to have a conversation about that. And again, before we lose you, Frederick, while ESA isn't a member of the Artemis Accords, because you can't sign as an entity, many European nations have. We just celebrated the Dominican Republic becoming number 44, Estonia number 45 to the Accords. And I was wondering if you could talk a little bit about what you see as the importance of the Artemis Accords, and particularly the non-binding agreements. And getting back to what Guoyo was saying, I think if we had to do a treaty, the Artemis Treaty, it would have taken us a decade, 8 years, et cetera. I'm very excited about the non-binding nature of these agreements because I think it allows us to proceed with more alacrity. But Frederick, your thoughts?
As a very famous philosopher used to say, his name was Groucho Marx.
It's my favorite Marx.
Before I speak, I have something important to say. And what I have to say before I speak is that I'm next to the architects of the Artemis Accords. And this contribution is actually a truly highly significant contribution for different reasons. And I will give you, again, I'm representing a space agency, so I will give you very concrete examples as to why we need that now and not in a fragmented, unfortunately, international community, stand maybe very little chance to have a legally binding instrument at the moment. Why is it so important? And I will give you just a few examples. We started to realize, I think, between the European, American, and Chinese operators of orbiters around Mars, that Mars ephemerid data was absolutely essential to make sure we would keep our orbiters at Mars safe. They're precious, they're expensive, you want to operate safely. We succeeded in doing this. And we succeeded because we absolutely needed this to be done. And when we talk in the Artemis Accords about deconfliction, that's exactly what it means. We absolutely have to have all the channels and the platforms, that we need to safely operate. And as a space agency, you can understand the urge and the priority placed there. Transparency. This is absolutely essential, and that's what we practice at ESA, because we believe through transparency we can actually achieve not just the objectives of the member states when they invest in ESA programs, but the broader objectives that we have, all of us, and in particular in exploration, to then put into practice and action the other principles of the Artemis Accords. To me, transparency is the engine of implementing all the other principles that you may know in this audience, meaning registration, meaning deconfliction, as I said, scientific data, and transparency about the scientific data, use of resources to sustain human presence on the surface. That's what we care about as space agencies. We are at the moment, because I take this opportunity to clarify a little bit this, because I hear from time to time in conferences that the space agencies are so focused on exploiting lunar resources. We are, as space agencies, first and foremost looking at lunar resources to help us sustain humans on the lunar surface. That's our primary objective. Companies may elect to choose a different path, but for us, this is absolutely essential. And so what the Artemis Accords have brought forward to the community is to start with transparency and then look for a course of action on all these principles. Member states, and now a majority of member states of ESA have signed the Artemis Accords. I think there might be some more coming in online. ESA is not a signatory. ESA is not a signatory of the Outer Space Treaty, and I have a colleague from the legal department of ESA in front of me, so I have to be very careful about what I'm going to say now. But it's actually first and foremost a member state decision, of course, to consider the signature of the Artemis Accords. But as a space agency, we care very much, and we are putting this already into practice as we build up our lunar exploration activities and plans and programs. We have a ministerial coming up in 25, another one in 27. That's the type of programs that will be considered by the member states, but we're building in exactly those principles in order to put, once again, the engine of everything, transparency, and then put all the principles into action. Once again, I truly apologize for my fellow panelists. I mean, sorry that I have to leave early, but that's the way it is. We have the fight that we have. But thank you very much again, and really thank you for listening to me.
Let's have a round of applause for Frederick. Thank you, my friend. Safe travels. Thank you. Appreciate it. And Frederick makes such an excellent point relative to transparency, which is at the very core of the Accords. You can really follow transparency to several of the other values, whereas the full release of scientific information, registration convention, et cetera. That is really the backbone of the document. And speaking of transparency, Artie, as we look at the challenges, I mean, you have a big job in front of you, extraordinarily challenging, which is why I'm so excited about the energy you've brought to how do we bring this diverse, sometimes divergent global group together to harmonize norms of behavior to the benefit of all.
Yeah, I would say that the biggest challenge, as we all know, is the politicization of these issues. The fact that it feels, it shouldn't, but it feels like we're still we're in some kind of a new space race. There's a real risk of two camps developing and a bifurcation of space policy, which we absolutely have to avoid. Even though, I must say, when we engage with member states, we do find that they are all asking and calling for the same thing in terms of safety, sustainability, interoperability, and so on. the challenge for us is to keep the delegates focused on the operational and safety imperatives that everybody actually shares. Whether we talk about satellites and space traffic management, whether we talk about lunar, you may have satellites for many different purposes. It might be for Earth observations, it might be for military and secure communications, it might be for something else. It doesn't matter, but you all share the same interest that you don't want them to crash. So we're really trying to keep them focused on, as I say, the operational imperatives. And here, excuse me, we're going to be doing a simulation exercise for COPUOS delegates. In January, we're running the United Nations Sustainability Days just before the STSC. And we want delegates to realize that the work that they're doing is not an academic exercise or some kind of posturing exercise. It could become a reality very, very quickly. And I think we should look at the example that we just saw with the 2 astronauts who find themselves staying a little bit longer than they anticipated on the ISS, just because of a discrepancy in the spacesuits, with no interoperability of spacesuits. Otherwise, they could have come back sooner, right? So there's a huge opportunity here, but we're going to be really reinforcing the role of COPUOS, something which has been underscored by the Pact of the Future. Heads of state have said that we have to do this in the one consensus-building body where we know that all member states will speak to each other and will participate. An important point to note there is also the challenge of how do you give industry a voice, knowing that there's such an important driver of these issues. I don't want to see member states losing an entire intersessional meeting debating or arguing about that. But again, I come back to UNUSA's capacity building role, and I think that we as an office can convene industry. We're actually doing that this afternoon right after this meeting around lunar activities, to hear from them, where does industry think that they can contribute? Can they somehow accelerate some of this consensus building work that we are expecting the delegates to do? And can we as UNUSA somehow run I don't want to say a parallel track, but work with industry and feed that in to the delegates to inform their deliberations and possibly help advance them?
Absolutely. I hope we can do some consensus building real time right here before it's over. But Guoyo, if you wouldn't mind, and again, let me preface that I think some people often conflate the Accords and ILRS, wrongfully so, that it's not, and forgive me for using an American idiom, but an apples-to-apples comparison, that the Accords are about norms of behavior in space, whereas, at least my understanding, is the ILRS agreements are bilateral agreements in terms of participation in the ILRS program, but there are some policy aspects that come along with that. So maybe, if you could talk a little bit about norms of behavior and how they appear and interact in the ILRS agreements.
Thank you, Mike, for that. It's not about a matter of transparent or not, because it's about whether you have something to share, to be transparent. So you mentioned that the joint statement, of course, it provides some general principles relevant to norms of behavior, like equality, openness, and integrity. It's just very principal things. As to the specific norms, is still under discussion. But personally, I shared with you before, I kept suggesting my government to consider to provide a more comprehensive, detailed legal framework for the consideration of potential partners of the lunar station, and as well as for the international community for the discussions in UN for elements, of course, further development. I'd like to take this opportunity, of course, to share briefly 23 articles, except the, we say the objective, Article 1, the glossary things. It has 11 principles and 10 mechanisms. So all of these norms actually are coming from the Lex Lata, existing legal framework. Some of them even from the Moon Agreement. But some of them actually just took the perspective of Lex Ferenda, looking for the future, something new. 11 principles like, some general things like cooperation, mutual assistance, we say for the benefits in the interest of all humankind, observance with international law, also how to interpret international law, exclusive for peaceful purpose, non-proliferation. These two were not mentioned in Artemis Accords. That's not the case. And also, we say the utilization, disposal, and sharing regarding in situ resources, very specific. And notification, consultation, information sharing, also including how to render assistance in emergency on the moon. And also reciprocal visits on lunar facilities. That's the principal things. As to the mechanism, I think you might be interested in it because I provide registration. Registration for lunar object is not new, but the registration of the facilities, installations, stations, it is not specifically mentioned either, in Auschwitz Treaty or the Moon Agreement. Then followed by jurisdiction and control. It's very legal things, but it's super important. Without the formal, so it's maybe New York to RT, people would just have the registration of the facilities. It's new. It's different with the registration over space object. And then international responsibility, crossing waiver things, also containing not safety zone, but coordination zone. Also, I'm also thinking to define the international scientific protection areas on the moon, and of course followed by the settlements mechanism there. So it's not, of course, not adopted by my government yet, but I have been done this for years. It should be sort of valuable. Even for the discussion among you Artemis Accords members. So last term here, I personally speaking, I would like to take the norms under the lunar station and Artemis Accords as competitive relation. They should just, you see, learn from each other, develop together, jointly contribute, the discussion in copious. That's the destination there. I just stop there. Thank you.
I couldn't agree more, Guoyo. There was what I thought was a really extraordinary event that occurred under Artie's leadership at the UN prior to the Copious meeting on lunar sustainability, where we had conversations from Artemis Accord signatories, ILRS signatories, and it sure seemed to me that there was far more common ground than even I would have ever anticipated, and that there was more that united us than what separated us. And Artie, having led that conversation, I'm wondering if you took the same thing from that dialogue, that in the end, we're really all looking for the same things, and that there's a singular opportunity for unity if we can grab it, as Guoyo's describing. Would you agree with that, or what would your position?
Definitely. When I came to the UN, I was struck because the office organizes various conferences, but it's not a conference in the sense that we in the non-UN world understand. Everything that the UN does is a capacity building exercise. So it's really to inform and educate usually developing countries and bring them up to speed with what's happening elsewhere. But this conference that we organized was the first public conference organized by the United Nations, open for anybody to register and attend. We had excellent industry participation, and I was struck by the fact that the governments really, really enjoyed the industry session. They kept firing questions at industry. They almost couldn't get enough of it. So lesson learned for us is we need to do more of these. And indeed, as you say, there was so much, all the governments were saying the same thing. Everybody from industry to government highlighted the importance of interoperability. I was surprised that industry did that, because industry usually wants to have a first mover advantage. They want to have competitive advantages, typically in the space sector, driven by proprietary interests. But here, the sustainability and safety are the drivers behind interoperability. Let's make sure that that scenario that we've just seen on the ISS, that could reproduce itself within the next 5 years on the moon. And then what? Do we really want to rely only on one country's ability to bring astronauts safely back? We're still one company. That's not a scenario that anybody wants to see happen. And I think that's really, there was a realization of member states that we have to really assume our responsibility to make sure that if such an eventuality happens, we can react together, which is the spirit of COPUOS and the Outer Space Treaty and all of that. The concrete outcome of that, well, was it of that conference? Was it going to happen anyway? Who knows? But one of the agenda items on the COPUOS's 2-week session thereafter was the creation of an action team for sustainable lunar activities, ATLAC. I believe that thanks to the push given by that conference and the positivity that came out of it, the excitement that, wow, there are so many areas of consensus, we saw ATLAC being adopted without any friction, any real debate and discussion at all. And ATLAC is going to convene in next month for the first time to discuss what is its work plan going to be. So we see that by convening industry and everybody together, we can actually drive some real results.
It was so interesting, even just at a superficial level at that meeting, that there were so many questions. Yeah. I'd never seen that many questions before at a COPUOS meeting. So it was pretty extraordinary. And Guo, you've kind of already hit upon it, but as we look at ILRS, as we look at Artemis Accords, at least at a broad level, it just seems, I'm not going to say identical necessarily, but almost close to that we are all trying to achieve the same goals. We're all signatories to the Outer Space Treaty, and it just seemed like such an opportunity to bring the world together. And so from your perspective, you also see that opportunity for us to work together to create unification for norms of behavior.
Yeah, thank you, Mike. Yes. I still remember, I personally raised a lot of questions in the June in the conference. It'll just provide, again, I have to say, it's kind of a historical moment, considering about the deteriorating geopolitical relations. It's the first time for the main stakeholders to share such specific information there. But as to how to avoid the division, fragmentation of the discussion, I have some, again, personal views there. I think Artie just mentioned that she disagreed with the saying the discussion in COP was just slow and without efficiency. I agree with you because personally I participated in the 8 years LTS discussion. People always say 8 years work just 21 guidelines, but it's not the case. Dozens of guidelines actually were discussed. So many things are discussed. So the 8 years, just the delegations, they know, they're getting familiar with each other, the legal points, technical concern. So, but in this case, no matter it's about the space traffic management or space resources activities, I'm hoping that the working group or ASPER group anyway, COPUOS, could provide some clear direction or framework, as a teacher to leave homework to your students, not just the topic, maybe with the outline, then just to avoid the fragmentation, this and that. So as to me, the 4 pillars to support the so-called international regime, no matter about what kind of domain. The first one, principles. So states, delegations are supposed to submit the homework regarding what kind of principles, they are leading principles, what kind of specific principles, and the specific rights, obligations. That's a legal, as a lawyer thinking of the different, partners or the subjects, and then followed by specific mechanism. But mechanism sometimes always be deemed as pragmatical, so people just would like to prefer talking about the mechanism rather than the legal issues. But they are, you see, systematic issue and followed by technical standards. So you see, you gave an outline and collect the homework. That's the idea there. And the last point would be, still we should be very patient about that. Process sometimes is slow, but I'm thinking, again, it's about the direction things. It's not about that they are lacking of the political will to do so. They need rules, they need the norms there. I stop here. Okay.
Yeah. And I think the Artemis Accords were always intended to be a beginning of a conversation, to act as a catalyst for just that kind of dialogue, to push us in the direction, have the conversations, find where we can get that common ground and avoid conflict before it occurs. Artie?
I want to turn it on to you as the architect of the Artemis Accords.
Sorry, we're out of time.
No. On the one hand, we could see the Artemis Accords as providing a basis for COPUOS member states to maybe, use that as some kind of a sign of consensus around these and continue the conversation in the broader setting. At the same time, every time there is a new signatory, it's effectively making a political statement. So it contributes to one camp, if you will. How do we reconcile that in your view?
So in my view, and let me say this, when we were drafting the Accords, and particularly United Arab Emirates, I don't know if we have any friends from UAE here in the room, but there was an effort to ensure that the Accords were as inclusive as possible. We wanted to make sure that the values of the Accords were universal, and that any country who has signed the Outer Space Treaty could become a part of the Accords. Certainly the position of the United States is that we're opposed to the Moon Agreement. I think we've got some very good reasons for that. But as we were drafting the Accords, it's not the American position. This was meant to be a holistic position to benefit the world, which is why we have countries that have signed the Moon Agreement that are part of the Accords. We have countries like the US that explicitly oppose the Moon Agreement. The Accords were about finding the common ground, how we can bring everyone together. So because of that universal, inclusive nature, when someone signs the Accords, I don't see it as saying, I am part of a camp. I see it as saying, I am standing up for norms that will give us a more peaceful and prosperous future, that it's a commitment to those values. It's a commitment not to a camp, but a commitment to peace. And signing the Accords doesn't preclude being a part of ILRS, being a part of discussions at the UN. If you read the Accords, and I definitely recommend reading the Accords, they're a page turner, brief, 8 pages. We talk a lot about COPUOS and the fact that we want to have broader conversations. So I don't view the Accords that way, and I hope the Accords signatories don't view it that way as well. That it's a commitment to peace, a commitment to a better future, and a commitment to actually bringing the world together. That language is in the Accords. Now, I would be hypocritical. I was just complimenting the number of questions that we had at the COPUOS, and I would be remiss if I didn't allow you, the audience, to actually ask some questions as part of this dialogue. So now I'd like to turn it around to the audience to ask questions of our 2 remaining Beatles that are left here. So any questions for Goyo or Artie? There must be some, otherwise I'm going to ask questions, and nobody wants that. Nobody.
Make it so clear.
Yeah. Absolutely so clear. Here we go. There's one.
So I would just say that that is a Geneva matter. That's more about arms control. That's not Vienna. Vienna is for safety and sustainability. Security questions are Geneva. And Goyu is the expert on that kind of thing, right? Do you want to comment on that?
Thank you. If I may, I just, because I participate the OEWG and all under the Paris GGE as a Chinese delegate, in the short term, it's hard to merge. Because they are just overlaps. They are not totally in parallel, right? But I guess if I have to offer a number 5 years later, sooner or later, they have to be merged into one. No country could support such kind of energies or resources to support a parallel discussion 4 times to Geneva. At least I cannot do it, right? But the direction would be, again, it's not about responsible behavior. It's not about the treaty. It should be about specific rules. That's it. Without mentioning, associated with its responsible, irresponsible. We just need specific rules to elaborate the general obligation in the treaties, say like due regard, like prior consultation, how to implement. Artie mentioned the guidelines. Actually, we're also facing the challenges to implement treaty obligations. So we need a list maybe 12, 10 paragraphs to say, keep a safe distance between the satellites, something like that. Just do it, do the specific things. As a lawyer, it's a matter of interpretation of law. That's it. So never, please, always talking about soft, hard, legally binding or non-legally binding. It's totally fake terms. So the example I just gave, raised there, you name it, it's legally binding or not. It's hard to say. It could be contained in the resolution. However, the paragraph per se might be legally binding because it might be deemed as interpretation of due regard. Due regard is legally binding. What can I say? So that's the only way I would like to share with you guys here, like you. The only way for the arms control future, just to focus on specific rules. Meanwhile, we can consider about the binding treaties in parallel. From a lawyer's perspective, the true parallel approach is not soft and hard, but it's interpretation of law and law making. So that's it.
So we'll end on the theme with the Beatles. I'm going to go Imagine here, right? Each of you, just 30 seconds or so if you can. In terms of unifying the global regime, norms of behavior, tell us what you imagine. What would you want to happen? Just blue sky. What would you want to occur to unite the world relative to norms of behavior in space? What would you want to see happen?
I would like to see a cooperation that kind of extends the spirit of the ISS into other realms and other celestial bodies. We were speaking with VAST yesterday, and I said, create your space station. Make sure that it has interoperable docks that any other party can dock onto it, so that we can have, even if you have individual components, they can work together. And also, we talked about one moon for all at our lunar conference, one spacesuit for all. How about that?
The Beatles really missed a beat. They never had a song about interoperability, but they should have. It's pretty big. Guoyo, you get the last word.
So I'm looking forward to see in the near future in Copious, I can see some specific, I can see some of my 23 articles just were adopted by the delegates there. That would be terrific. Then people consider about, okay, we have a new treaty or come to new agreement, make some good modification. That's totally another thing because we already have the common legal understandings there. That's super important for the next move. I think sooner or later, I'm very optimistic about that. Under your leadership, Ati.
And what about you, Mike? What do you imagine?
I mean, you asked the question about the camps with the Artemis Accords. I view the camp of the Artemis Accords as the whole world. I would like to see the whole world sign the accords because they were designed for the globe. So that would be my personal love. But if we can't achieve that, at the very least, I'd like to proceed with what you've worked on and what Guoyo said, that let's find the common ground. Let's find how we can come together because there's more that unites us than there is that separates us. And let's do it with alacrity. Let's do it before the problems occur. In the end, what we were trying to do with the Accords is a preemptive strike against conflict. Again, our journey is going to be the moon and Mars, but if we work, thank you. If we work together, our destination can be peace and prosperity. And with that, let's have a round of applause for a terrific space policy work. Thank you.
It's down here. It's down here.
Yeah, don't do that. Very.
All right.
Well, you would have to
All right. Hello, everyone. Welcome to our Global Networking Forum session on innovative lunar lander technologies for sustainable exploration. My name is IAC Charania. I am the Chief Technologist at NASA from Washington, D.C. and NASA headquarters. And I have an esteemed panel that represents a wide assortment of lunar lander experts and pioneers within the world. And I was very excited that we can host such a panel. And we're going to make it very conversational and hopefully not a lot of kind of PowerPoint kind of efforts, but here a good conversation of the innovations, the challenges that this group kind of has had in the various global endeavors for sustainable exploration. I do want to make the point that we will have, if we have time, we will take questions from the audience on Slido, and I believe you might show a QR code. So please note this QR code, and as we go forward, if we have time at the end, as I said, we will take questions from those in the audience. So with that, if we want to begin, so on the panel here today, I've got a whole assortment of innovators, and so I'll probably use everyone's first name as we talk to each other. And so we have Tim Crane from Intuitive Machines. We have Masaki Fujimoto from ISIS JAXA. We have Dan Hendrickson from Astrobotic. And we have our friend Vera from ISRO. And representing all the United States, India, and Japanese innovation in terms of lunar lander technologies. All right, next slide, hopefully. So there's, I'll just start and preface in terms of some opening thoughts from me as moderator. There's a lot of missions happening. This is a NASA slide, obviously, of the various missions, both human and robotic, that we have over the next several years. And this is not complete in terms of what all the world is doing. But I think it's a good representation of the interest within government agencies, commercial industry for both crew and cargo services, and the innovations that are happening in cislunar space. So the bottom line is there's a lot happening, a lot of innovation. And these are not just innovations using the same existing technologies. There are new deorbit descent landing sensors, new propulsion systems, new survive the night systems, new hopping systems, new imagery, new capabilities that all of these providers and developers are providing. So it gives you a sense of that. I will take actually time for a little commercial for myself. Is actually, I'm hosting a lunar autonomy mobility pathfinder workshop in a few weeks in Las Vegas that's looking at autonomy throughout this ecosystem of surface mobility that these entities on stage are enabling. So just a short plug for me. And then finally, this picture, which is my last picture in the introduction, which shows you the accomplishments of the people on this panels. So these are real pictures. These are not PowerPoints or fake images. And I, in fact, would recommend to the IAC that I do this panel every year. And next year, I have a whole different set of innovators on the panel with me. But these are the innovators from this last year or so in terms of real hardware, real landings, real attempts at getting to the moon and to the lunar surface. Some successful, some more successful than others, some having challenges, some overcoming the challenges. And that's a great story of innovation. Sometimes that innovation works, sometimes that doesn't. Sometimes you overcome those challenges, sometimes you hotwire those kinds of programs to make it successful. And that kind of excites me in the world of innovation. So kind of with that, let's start the conversation, and we've got about 50 minutes left here. And maybe I'll start with Fujimoto-san. In terms of, can you talk about the various technologies and the early missions for your Japanese spacecraft and lander that you leveraged in order to accomplish the missions? That's probably the question that I'll start with for all the panelists and go panelist by panelist. So.
Yeah, I'm from the Science Institute of the Japanese Space Agency, and this, I think it's an iconic picture, but it's from our mission, which landed on the moon successfully on 19th of January this year. It's a very small lander. We call it SLIM, Smart Lander for Investigating the Moon. So S is also not just only for smart, but also for small as well. So we really wanted to make our mission small and smart. But at the beginning, it started with a kind of collapse of a big mission concept we have had 20 years ago. We had a nice lunar orbiter by the name Kaguya, and everyone thought that, oh, next step is the lunar landing. And everybody got together, and then the mission got beefier, and then it collapsed. But out of that ash, there were two guys who thought that pinpoint landing on the surface of the moon must be demonstrated. So those guys I think had the motivation in the correct shape, kept on working for 15 years, and they came up with a big success. So it's the pinpoint landing by optical navigation that this small mission demonstrated. But because it's such a small mission, you only have limited resources. So how do you put all the algorithm into the limited resources available on this small lander? That really was the key challenge that the team members faced, but they managed it. What I mean by is that you really have to do all the processing very quickly. So how do you do that with limited resources? So they have to come up with a, again, smart algorithm to do so, and they did. And we ended up with this safe landing on the moon. By the way, it looks to be in a very acrobatic orientation on the surface of the moon. This is not something we planned. There was something wrong that happened at the last 40 seconds of the mission. But the pinpoint landing technology was already demonstrated at 50 meters above the surface. So this final 40 seconds is like giving us a charm to the mission and giving us even more motivation to the next mission.
Thank you. Going next to Tim from Intuitive Machines. On your first generation of landers, kind of the biggest technical challenges you had?
The key difference between a lander and just a spacecraft or a satellite is the amount of high impulse thrust you have to manage. And so really the whole lander system is built around managing propulsion from our perspective. And we had 4 things that we couldn't test until we got into orbit. We couldn't test the exact performance of the engine in a vacuum. We'd approximated it with a number of tests terrestrially. We had simulation and modeling. We couldn't test the free vehicle control of a large single engine gimbaled spacecraft. So we didn't have multiple engines. We're steering with a 2-axis gimbal. You can't free fly that in 1G. So we had to wait until we got into our first engine burn to confirm that our algorithms actually worked on an actual vehicle without lockdowns. Radios at lunar distance. So we tested the radios, but it's all simulated delays and attenuation. How are we actually going to perform 380,000, 400,000 kilometers away? And finally, our sensor interaction with the lunar surface. So we did camera modeling, we did camera testing with perfectly white images as much as we could, but the actual photons from the sun reflecting off the moon, hitting our cameras, the actual photons from our lasers hitting the moon and coming back, those are things that we tried to bracket. So the challenge for us was getting the risk mixture right, where we felt like we had done enough terrestrial testing that these systems would perform, and then demonstrating them orbit for the first time. And fortunately, we were able to check the boxes off on those, but it was something that we spent a considerable amount of time looking at. How do you go from the successes of other programs, how do you go from the historical achievements and demonstrated approaches to landing on the moon and implement your new specific system and get enough testing that the residual risk on orbit is something you can accommodate. That was the big risk for us, the big challenge.
Our friend Vera from ISRO, in terms of the similar question for your incredible mission that had multiple components, some of the biggest technical challenges.
Thank you for the opportunity. As you know, the fundamental difference from the orbiting mission to the landing mission is it demands for new technologies and new systems. So one of the system is the sensors, which gives position and velocity information. In the absence of GPS in the moon, we have to use a terrain relative navigation sensors. So we developed a set of sensors which gives position information. We had altimeters, which works on radio wave frequency and laser-based principle. And also we had a velocity measurement in all the 3 directions. We had a new sensor called laser Doppler velocimeter. And also, towards the end, we have to avoid the obstacles, for which we used Lambda hazard detection and avoidance sensor, which is a camera-based sensor, where we took a picture prior to the landing, and we are stored on onboard. And just before the landing, we took a picture and compared with the onboard image, and by which we were avoiding the obstacle. That was one of the intelligence built in. And the second technology is the propulsion system, where we require a throttling engine. And we used multiple engines with 800 Newton capacity. And the throttling range is from 800 Newton to 400 Newton. And this is required during hovering stage and various stages of deceleration. So we developed a new technology with the throttleable capacity. And also we require a landing leg technology, landing gear mechanism, where we have honeycomb-based dampers, because we have to, at the time of touchdown, it has to offer the stability as well as it has to give a necessary strength. So we designed different touchdown conditions, like it can tolerate up to maximum of 3 meters per second in the vertical direction and 1 meter per second in the horizontal direction, and it can tolerate a slope of 12 degrees. And also we do not know the terrain conditions, whether it is hard or soft. So according to that, we have developed multiple technologies. And also the mission design itself, as we were to utilize our own launch vehicle, which has a limited payload capability. So we have designed the lander of about 1.75 tons. And this lander has been carried by propulsion module, which will be taking the lander all the way to the moon, and where the launch vehicle is injected. And the launch vehicle has a capability of injecting approximately 4 tons of mass in GTO. From GTO, we have to go to the moon, and we designed a trajectory from GTO to the moon orbit. And finally, we had a set of deboost maneuvers, and then finally landing. And the landing itself, we designed multiple design trajectories, particularly on the algorithms, navigation, guidance, and control algorithms. And that also is a very new technology. And finally, upon landing, the tiny rover has to come out, and that also is a challenge, because we have to have a necessary orientation which has to look at the sun upon landing. And we have designed the entire lander for 1 lunar day, which means the precise landing and the orbit, the orientation of the lander has to be very precise, so that the rover comes out of the lander with the necessary systems are in place. So these are all the multiple challenges we had. And moreover, to qualify these systems, we had multiple simulation test beds, which captures all these failure modes. And to substantiate that, we have to conduct a necessary test. That is one of its unique tests, where we have to do at outdoor, like integrated cold test, wherein all the sensors have been characterized thoroughly for the dynamic conditions with the required altitude, with the required velocity, and also the propulsion system in loop with the navigation, guidance, and control. That is another challenge. We have to really see the closed loop is working. And also, finally, we have to qualify the lander legs. So we developed something like a lunar simulant test bed for characterizing the stability conditions. So these were the challenges, I would say. And finally, we succeeded. Thank you so much.
All right, that's always a great story. So now, Dan, you've had some interesting experiences in that first mission and lessons learned. So I'd be curious on some of those technical challenges. I know you all have various follow-on missions as well, but I think I'm interested in your thoughts as well on this.
Yeah, thanks, AC, and thanks for the opportunity to be here today. In Astrobotic's case, we had a really significant anomaly that occurred in flight. We unfortunately had a valve failure that proved to be the most challenging technical issue that we had in the entire mission, for obvious reasons, in that we had a rush of helium coming from the pressurant tank that entered the oxidizer tank and caused a rupture. It was at that point we recognized it was not going to be possible to do the powered descent because we wouldn't have the proper pressure. But we quickly pivoted the mission and focused on a few things. One was to get as much payload data for the customers as possible. In fact, 3 of the instruments ended up getting publishable science. So bittersweet result. We're really glad that still occurred. But then we also focused on getting as much data from the technical systems and the subsystems, to diagnose the valve issue, to understand what we needed to change for future missions, but also to prove out the rest of the subsystems on the vehicle. It's a little funny to say, but everything else on the vehicle worked as planned. So that kind of goes back to that point that I think you were making, Tim, in that you kind of have to make choices of what risk tolerance you're willing to take on particular subsystems. And one of the things that we're really excited about in this new era is that there's the opportunity to finally iterate. So now we're going to go back and we're going to add a pressure regulator in front of the valve that failed. We're going to add another valve after. We're of course also going to make a mechanical design change to the original valve. All those things allow us to make changes to assess where the weak point was. And again, everything else worked as planned, so we feel very confident about moving forward, and we've got an opportunity to, again, understand where the weak points are, iterate, and then fly again, ultimately.
All right, thanks, Dan. Maybe I'll come back on this side to Masaki-san for the next question. So we've had a good conversation from all of the panelists on these missions that you see here before you. Now I want to go a little bit to the midterm and farther term as we go forward in the conversation. So as you look, all of you, I'm sure, had interesting experiences, successes, lessons learned, and you're going to build more landers, hopefully, all of you on stage. So as you look forward to those later generation of landers, what are some technology gaps or shortfalls, as we call them, that you're thinking we have to solve these challenges and shortfalls for the future generation of landers? So maybe Masaki-san.
Again, might want to talk about this SLIM mission again. So we had two primary objectives. One is to demonstrate the pinpoint landing technology, which has been successful, but the other one is to demonstrate the two-stage landing scheme, which should be useful to land. If the terrain is rough or has a slope, we should be able to land on that spot safely. That was supposed to be demonstrated, but we could not because of this last 40-second trouble we have had. But what I want to tell you is that pinpoint landing technology and two-stage landing scheme, that should come in on combination, because if you tell your customer that you have the pinpoint landing technology, then the customer tell you, can I land here? And if there's a slope, and then we're going to have to tell them, if you don't have maybe if you don't have the two-stage landing scheme, you're going to have to tell the customer, I can navigate you there, but I cannot land on the surface, which is almost like a scam, right? So we wanted to demonstrate the combination of the two technology, which we think it's the smart way of performing a small missions, but we could not. So yeah, so what's the next occasions for us to demonstrate the two-stage landing? Oh, by the way, two-stage landing is you can tell, our lander doesn't have legs. So instead of legs, we do have five, something like a sponge, you know. And then contact with the surface will happen only with one of them, and then you change the orientation of the spacecraft, and you contact the surface as if you're clinching onto the surface. That's the way I mean by two-stage landing and safe landing, whatever, even if you have a slope on the point you want to land. But we haven't demonstrated yet. So what's the next occasion? That's something is in my head now. Yeah.
Very good. Tim, next question to you. I know we've contracted at NASA with you for a few missions. So as you think about these later missions and even your roadmap, what are you looking at in terms of tech shortfalls?
Well, you know, one of I think the common themes you'll see of all four landers, and by the way, how cool is it to have four landers on one screen that have all landed or attempted to land in the last year? It's really, really exciting times. You know, all of these landers are very lean. They're small landers, really set up to demonstrate the core technologies in a lot of cases. Small amounts of payload. What that means is once we land, we're going to get operations through the lunar day. And then when the sun sets below the horizon, our systems are going to freeze, and then that was it. And so we kind of have this one-shot mission at this scale of lander. But as we begin, really as a cohort of organizations building landers, to move to the next generation, and now you're talking about landers with 500, 1,000, 1,500 kilogram capacity, we have an opportunity to begin looking towards survive the night. And now, these become assets and part of a lunar infrastructure to provide communication nodes, to provide navigation resources, to be literally a power and warming station for other vehicles, but for us to have use of these systems over and over. And right now, all of our first generation landers are kind of one shot for a lunar day. And we really need to take the step as we perfect these technologies. And it'll take a few more flights. I mean, the moon's a tough challenge. But I think that will be where we really see the same way we've seen reusable boosters change the launch game. Persistent assets on the moon really put us on the path to sustainability where we can build up infrastructure.
Vera from ISRO, as you're looking at future landers as well, what are the biggest technology gaps, shortfalls you're trying to address? Yeah, and I know you've even got joint missions with JAXA as well. So yeah, curious.
Yeah, we have a series of missions post Chandrayaan 3. The next mission is sample return mission. So it calls for different kinds of technology. We have to come back with the sample back safely to Earth. So it calls for a docking in space and then escaping from moon, and then also we have to cross through the atmosphere. So we require a re-entry vehicle. There are a lot of challenges. And also for the future, the gaps I would say is long-term survivability. Right now missions are having one lunar day because we are heavily depending on the solar power. So we should have some mechanisms. Either the systems has to be qualified for a very low temperature working conditions, because we are also planning to explore permanently shadowed regions. That are the science aspects we are looking forward. So for which we require either nuclear resources, or we need to see that any other mechanism is available to have a long-term survivability. This is going to be the key. And also some of the asserts are required for the relay communication and navigation purpose to have a precise landing. And also now the trend is going towards the pole. And there the sun elevation angle is very, very low. And we are using visible sensors, and these algorithms, how it is going to work, and how the terrain conditions are going to be looked at. These are all challenges ahead of us, and we have to qualify those sensors with the different integration times. So these are all the big challenges we have.
Same question to you, Dan, but you can't use the answer of survive the lunar night. We've already heard that one. So give me some other challenges.
Because that's actually going to echo that, but I'll maybe take a different approach. I think there's going to be some unique tech challenges that will come from needing to go to the same location over and over again. I think it's great that we're going to have landers capable of going to multiple locations, because there's a lot of science to be done, and you can't necessarily go to the same place every time to do it. But with that said, I think a lot of folks are really focusing on going to the South Pole. And so, yes, you need to survive the night. We're big fans of things like micro power grids to help make that happen. But you're also probably going to need things like landing pads, because you can't have the abrasion of every lander coming down over and over again in a limited area. And when you combine that with things like potentially even beacons for the ability to actually do maybe TRN-less, so non-terrain relative navigation down to the surface with beacons that already exist, those are things that I think are well within our capability to develop, but they're not ready yet. So we need to work on those technology shortfalls so that we can go and do all of this sustained presence that we're looking to do, particularly at the South Pole.
Thanks. And the next question, I think, goes to the theme of the IAC this year in terms of sustainable exploration. So I prepared the panelists with this question, so it shouldn't be a surprise. So, and specifically, let's talk about sustainable exploration. We can talk about it in the abstract, in theory, but you all are at the tip of the spear, as one would say, in real exploration, as we see in these pictures, of people who are actively exploring the moon. And as you think about it, how do you think about exploring the moon in a sustainable fashion, to the theme of this year's IAC? So this is maybe less of a, it could be a technology question, but maybe a broader question as you are innovators and not just talking about sustainable lunar exploration, but actually exploring the moon and thinking about it. So maybe Masaki-san.
Yes, I'm a Deputy Director General of the Science Institute within the Japanese Space Agency, but I also belong to the Japanese Space Agency, which is in charge of the big pressurized rover to be deployed on the surface of Mars, of the moon. So we get to be invited to participate in the conversation, because science is always the central topic for even for such a big asset. But on the other hand, at my institute, we work on smaller missions, smarter missions. So yeah, how do you define the constellation? Variety of landers or rovers, so that that will enable more and more people to join and play a meaningful role in the exploration of the moon. That it's not just a slogan to me. That's something real, because I know both elements. When I wear my space agency hat, I do talk about big pressurized rover, but in my institute with my colleagues, I talk about how to make our smaller missions even more smarter. So yeah, it's this. How do you define the nice? Maybe it's the architecture discussion, but how do you define the way of inviting more people in and let each size of the missions to play meaningful role while the humanity explore the moon? I think that's a nice topic to talk about. Yeah.
I think, just taking an aside, I think in the United States, from my perspective, we have both the CLIPS program, the Commercial Lunar Payload Services, and you see two of our providers here. We also have the Human Landing System program, and I like both, and I think both are synergistic with each other. To your point, we have big programs, but we have smaller programs as well that hopefully are growing as well, and both can work together. So Tim, kind of same question on sustainability, and what's your thoughts there?
Well, not from a technological point of view, but from a planning and philosophical point of view, moving from a single encapsulated mission mindset to a campaign mindset, where you might say, okay, on this mission, we're going to land and we're going to deploy, and we have some very important science things and some demonstration things we're going to do. But I'm also taking something that's going to be put in place for a subsequent mission to come and then utilize that as part of what it's doing. And now you look across an architecture and it changes your perspective. We've begun working on our lunar terrain vehicle, which has a trailer attachment. So we think, well, I have one LTV, but what if I had many trailers with different power, communication, science packages on different trailers that are delivered at different times? And when we begin working and even working across organizations and saying, well, I've got this mission where I'm taking Article A, and then I have Article B that's going to this next mission, but I'm missing something else. Might we call a competitor up and go, hey, I know you've got room on your manifest, or call up other space programs and say, look, we're moving across multiple missions to do something sustainable, maintainable, but beginning to think about that architecturally and in a campaign sense, where we'll say, okay, I will do some things that build up as we go, and we're not in an encapsulated single mission mindset. And just things like building landing pads, because you're going to build up on that. And how cool will it be to go from being observers to builders on another celestial body? That's going to be a monumental moment, I think, that'll lead to that sustainability.
Observers to builders. Okay, that's good, interesting quote. Vera, your thoughts on sustainability?
I would say the infrastructure requirement around the moon as well as on the surface is also crucial for the sustainability. Like, for example, how we have a space station around the Earth, we should have some kind of a gateway. Anyway, Artemis program is having, and we should have even our ISRO is planning such plans beyond the crew landing onto the moon. So we should have our own architecture, or we have to have a joint venture so that there will be a shuttle between the Earth to the moon, as well as from the moon to the surface. We should have another reshuttle, so for which new technologies are required for cargo as well as a crew transfer, as well as to create a lunar station for a constant human presence on the surface. We have to see that how we have to utilize the regolith or soil to construct and develop an infrastructure. These requires different kind of an instruments. Like, lot of study is set to take place for a constant human presence, and also the infrastructure required for a relay satellite and communication, relay communication and navigation. Even though for Chandrayaan-3 we utilized different DSN network apart from IDSN from ISRO, we have utilized JPL 3 stations and ESA 2 stations, but still we were having a visibility gap. So in order to maximize the payload operations, this is also very crucial. So now the Moonlight program is there, and we too have our own, we are thinking of having some more relay satellite communications with the highly elliptical frozen orbit with the 2 inclinations. So such things are required around the moon as well as on the moon.
Dan, your thoughts on sustainable lunar exploration?
Yeah, thanks. I love the mention of Moonlight in the sense that it speaks to, I think, a sense of sustainability where folks are specializing. The idea that we're all going to build landers forever and everybody's going to be doing delivery missions. I think if we look back, 15 years from now, and if that's still happening, I think we probably failed in the sustainability department because cost matters. It's really expensive, as it's been pointed out on this panel, to just keep doing singular missions one at a time. So, in our case, we want to focus, we're going to continue to focus on delivery, but we really are excited about providing power through LunaGrid. And in that case, we feel like that's an opportunity then for other space agencies, for other companies to make use of power that's already there and then not have to bring the power solution with them every time for a HAB, for an LTV, for a science package. And so if you have, I think, specialization, that's one of the hallmarks that you've got the beginnings of something that's truly sustainable because it's going to bring down cost. And it's also going to invite other players to the table. They can see a role for themselves that might be a little bit different instead of a really high capital intensive activity like building a lander and buying a launch vehicle.
Thanks. Now, I think last question before we maybe go to the audience. And I will ask all of our panelists to take off their agency institute hats right now, and just as humans and smart individuals with me on the stage. Let us travel through time. It is now the year 2040. We are many years from here and many IACs from now, and who knows when we'll meet again in 2040. So I'm with you at the 2040 IAC, with all of you again. Give us your impression of what the moon looks like in 2040. All this activity that we've heard, from landers to infrastructure to cislunar space assets. What does the moon look like to you? And what is the vision of what a 2040 cislunar surface kind of image in your mind that we can aspire to or get to? So Masaki-san.
Yeah, so I don't know how you guys came to this venue, but if you go outside this building, there's a nice big green area where people are walking their dogs. So in 2040, on the surface of the moon, I hope the same is happening, but not the dogs. Astronauts walking their small rovers around it and exploring the environment in a very creative way. It's like what geologists do on Earth, not just following the instruction that's been prefixed, but the exploration has to do it in a more creative way. And maybe the swarm of small rovers may provide the tools to enable such a creative exploration. That's what yeah. So once you go outside this building, watch for dogs. And yeah.
Tim, 2040, what does it look like?
Well, the lunar orbit crosses the Earth's equatorial plane. We have the alignment of the nodes twice a month. And I think what you'll see spacecraft on their way on every ascending and descending node. And so in the same way we've become used to seeing regular launches into low Earth orbit, you will see the launch window opportunities to the moon with a regular cadence of launches every month, twice a month, 3 times a month. Returning vehicles are going to be bringing samples, materials, manufactured goods back from the moon in small quantities. And we'll have not only ISRU, but we'll have built habitats from lunar material at that time. And so by 2040, it won't be just the beginning of human habitation on the moon. The first lessons learned from human habitation on the moon, I think, will already start coming in, and we're going to be making refinements in that system. So it's going to be a very exciting time, and we're getting to the point where we can perfect the basics of transportation and communication and power management. What we as humans collectively do, the opportunity for cooperation there on a very vibrant Earth to moon and back and forth again transportation model. It's going to be exciting to watch.
So we may have a launch of a lunar lander at the beginning of IAC in 2040 and a landing at the end of IAC.
That's right.
That's true. Okay, all right. Vera, 2040, what does it look like to you?
Yeah, ISRO has put a target by 2040. We have to have Indian astronaut on the moon. That's what our target is. Before that, we will have a series of missions, both for science point of view as well as from ISRU point of view. And a lot of technologies we need to develop before the crew landing. And also, with respect to the previous question, lot of activities will be taking place on the surface as well as around the moon. And a lot of transportation reshuttles will be happening between the Earth and Moon. And we can see a lot of activities. That's what I can visualize now. Thank you.
Dan, 2040.
So I think by 2040, we will have demonstrated it's possible to extract a resource, and the first entities that are not space agencies will be pursuing actually closing the economic case to do it, having seen the demonstration and starting to gear up for a major investment and looking at doing that for the first time. I won't posit which one, which area, which resource, but somebody somewhere in one vertical will have started to make some serious progress.
All right, thanks you. Can we get the Slido slide back up? And I've got a few questions, but we still have a few minutes for those that have additional questions, and I will review them and then pick one. And so in terms of maybe first to Tim, and the question is, are you planning to upgrade the Nova Hopper technology to provide future delivery surfaces on the moon's surface?
Yeah, absolutely. So the Micronova hopper that we're flying on IM-2 was sized to provide 8 kilograms of payload, 25 kilometers of range. However, that's a propulsion sizing activity. So as we get to specific customers who say, well, look, this is exactly what I want to do and how I want to fly, we can upsize or downsize the tank and begin considering refueling technology. So once we demonstrate the basics of the hopper drone activity, customizing that then to be very specific, whether it's as an astronaut's survey assistant or a very low altitude science platform, is something we can specialize into once we've demonstrated the core technology.
Okay. This next question I'll have both for Vera and Masaki. I think it's an interesting question, and your two organizations, well, ISS, JAXA, and ISRO are with future missions are very interesting. The question is about interoperability. Maybe for you two, what is your vision of interoperability required for cooperation between different parties? And you probably know what I'm talking about in terms of JAXA, ISIS, ISRO cooperation on future missions. So in terms of interoperability between multiple parties, multiple elements, multiple systems, how do you think about that?
You are asking specific to Chandrayaan, Loop X mission?
No, just generally, and if you want to add specifics, It's up to you.
Yeah, the one of the thing is interoperability is very important for the infrastructure utilization, particularly, say for example, Moonlight. We have series of satellites. We should utilize that resources. So for which we have to have communication frequencies, which has to be compatible with respect to the rover or landing mission, with respect to orbiting mission. So this is something very important, as well as for the future thing, like we should standardize like what kind of a payloads it can carry, what kind of a rover capacity it can carry, what is the available resources. So which should clearly define it between the agencies, so that this will be like a shuttle standard platform which can deliver the payloads onto the surface or around the moon, things like that.
Yeah, it's a very interesting question because I've been attending bilateral meetings, and at many of them there was a conversation about interoperability, and yeah, because now Artemis architecture conversation. We have that big picture, and each space agency or whoever is starting to prepare to say that I will provide this. I will make this. Then think about you think about the fitness to the architecture, and then say I will provide this element in the whole program. But once you say so, we tend to focus on what you're delivering. And maybe end up not talking enough about the interoperability. We're good at this, like the collaboration between JAXA and ISRO. When it's a bilateral collaboration, we do talk about interfaces and blah, blah, blah. But when it comes to providing an element in that big program, and who's going to control it, and you know what I mean? Yeah, I think you're in a position to say your opinion about this, I guess.
Interfaces are important. I think, I think in terms of architectures, in terms of the Artemis Accords and having elements together, amateurs talk about propulsion, professionals talk about interfaces, one could say, So I think that's going to be important. And also, I think to Tim's point, my perspective would be interfaces that you can repeat and are repeatable, docking standards that are out there, that are known, et cetera. So I think that that's probably some thoughts there.
We have a conversation on LoopX. So I was always wonder that this kind of conversation, can it be applied? Can we hope we don't have to repeat this because no. Yeah.
I think of the CubeSat standard. What we see today on the small satellite side was enabled by a standard from a university that other universities could take and build upon, and now they're building 50 kilogram, 100 kilogram satellites, but that standard helped innovate and continue to innovate. Maybe now to Dan, a question is, I thought this was an interesting question in terms of 60 years ago, surveyors successfully landed on the moon 5 times. Did that experience provide technical insights to the US providers, and is NASA capturing lessons learned from these and other missions for future use?
Yeah, absolutely. We were very grateful, actually, that NASA had set up a no-funds exchange program called Lunar Catalyst back in the day. And that was enormously helpful because we got access then to lots of legacy understanding and data, but then also actual folks that are still working the agency. So combined, it was really helpful for us to be able to at least cross-check what we're doing. We didn't always necessarily go the way that NASA would have gone on a particular solution, but it at least allowed us to round out our thinking and to be able to pressure test, if you will, certain ideas, certain approaches. And so 100%, I think, not only from those missions, but all of the missions, everyone up here and other missions that have happened, we pay close attention. And it's always been, I think, really heartening that obviously there's a certain amount of information that you have to hold proprietary, but at the same time, the community's been generally pretty open about the key lesson learned from each mission, and we've all benefited from those key lessons. And so I think that's what's going to make all of us stronger and better.
Yeah, I'll just add to that. We had a conversation with an engineer from Beersheba, the Israeli lander earlier. There are at least 4 improvements we made on Nova C in its design and development as we watched other people complete their missions. And we went, oh, wow, that got them. Let's change that and modify that right there. And so sometimes it's formal, like the reviews we had with NASA after our missions where we exchanged them. Sometimes just watching someone else make the attempt. And then when the other teams are open and forthright about, well, okay, look, this is what happened. At the minimum, it gives you a chance to go back and look at your design and go, am I susceptible to that? And if the answer is no, good on you. Right? You beat it before it happened. But there are 3 or 4 times, I'm looking at Trent in the back and make sure I've got that right. That I know 2 of them, he and I were sitting in a room together watching someone try to land and went, oh, get the eraser out and just fix that right now. So it definitely builds for a community.
I think this is the reasons I want to do this panel, of the moment that just happened, because what you noticed is one lunar lander provider is talking about the lessons learned for another lunar lander provider. So in 2024, this is where we are. This is the future we tried to get to in terms of a lunar ecosystem. And I think you just described such an ecosystem of lessons learned, et cetera. I think we have another series of questions going to the Slim lander, Masaki, on surviving the lunar night, thoughts about that. So I think we had several questions on that. So I'd kind of ask you to talk about that.
Well, I don't think I can answer those questions because we didn't design it, but it happened 3 times. So night survival by the smallest lander on the moon for 3 times. And yeah, we were supposed to be, how do I say, we're supposed to be like, yay about this, but we just didn't design it. So what can I say? Maybe made in Japan quality. That's all I can say.
Maybe to anyone in the panel about larger lunar landers. You know, as you think about kind of going upscaling at larger capabilities, sample return capabilities, et cetera, how do you think about moving out, expanding your system capabilities? I don't know, to anyone in the audience, yeah, or in the panel. Yeah.
Well, we want to. Basic economics, especially for the commercial landers, is with a smaller amount of payload, that's all you can really monetize to pay for your booster cost and your lander cost. However, what you typically find is, we're going from 130 kilograms with Nova C to somewhere north of 1,500 kilograms on our cargo class Nova D. So it's an order of magnitude increase in the payload capacity, but it's not an order of magnitude increase in cost. And so what that allows us to do, and especially in terms of offering more people access to the moon, not only can we take more mass, we can reduce the price for the transportation that we are doing. And it's very much analogous to what you see in the booster industry. That as we got bigger boosters, the price per kilogram came down. So I think moving to the larger landers is essential for us to be able to open up not just more stuff you can take, but to bring the price down so that more people can participate.
Yeah, I'll add, I think it's essential. I mean, ACU pointed out that the HLS program out of NASA, fantastic, but those are very large landers. It's going to take quite a bit of cargo to fill one. And at the same time, too, I think we all have ambitions to have payloads that are larger than maybe some of the scales that we're currently launching at for the landers that are on stage here, being represented on stage. So there's definitely a niche, I think, that need to get to that multi-hundred, at least, kilogram delivery, if not multi-metric ton, because there's going to be a need for things like T-shirts and toothbrushes to Artemis. They're going to need resupply, and you don't necessarily want to human rate every single lander that delivers that kind of cargo. So there's very practical reasons to go to that larger scale, hopefully in the near term.
Let's see, kind of a more market question or demand question. What's a killer app, you think, the question is, killer application that would free lunar lander services from depending upon government funding exclusively? Killer apps, what are your thoughts? Anyone on the panel?
Resources.
Resources, all right. Okay.
Yeah,
one word.
That's an easy one. Certainly there's a variety of different ideas and approaches. I think that's the most obvious one. It's not to say that's the easiest one, though, either.
All right. I will take moderator's prerogative to ask a question I didn't tell you all I'd ask you. So, okay. All right. You're okay with that? Okay.
Go for it.
All right. I magically have $20 million in my pocket. Okay. I'm giving you $20 million to mature a technology immediately. What technology would you immediately apply that for that you're not already funding? So there you go. All of you have to answer this question. So you got 20 million. AC is giving that to you, not NASA, but AC. What are you going to invest that immediately in terms of a single technology advancement for your entire program? Down payment on a technology advancement.
So one is the propulsion technology. For example, we have to increase the specific impulse. Largely, the moon mission is driven by the propellant requirement. So the payload mass at the surface is very low because the large mass is spent in the propellant. So the more the specific impulse is, the better the payload mass. So if we have engines like cryogenic engines or locksmith engines, where we have a better ISP than the chemical, bipropellant systems. So if we have that, how to manage thermally and how to stay for a longer time, that will be the key. I would go for that.
All right. I'm going to spend $20 million on valves.
Valves, all right. Okay.
Yeah, I'm right there with you, Dan. I'm going to spend $20 million on the biggest antenna I can get to deploy to bring data down, because the value of the moon is what you bring back. And right now, what we bring back from the moon is data. And we had a lot of help from the internet when we landed that we weren't bringing enough pictures home. More ability to bring that data down. Now, the Moonlight, Near Space Network Services, the constellation is going to help, but I would immediately improve communication technology.
Yeah, Lunar Night Survival Module. Next time we design it so that we can survive. Well, seriously, when we talk to our scientists, there are two big science themes we are trying to pursue on the surface of the moon. One is the seismometer, and the other is the radio astronomy on the far side of the moon. And both needs to continue observations for months, like a year or more than a year. Then you have to think about the survival, lunar night survival. So, and the radioactive heating unit is a sensible topic in Japan, but still, reasonably, you have to go for it. So, yeah, survival module.
And then maybe a final question to the panelists is talking about your experience. You'd mentioned comm and in-space comms, and let's talk about the ground networks, the ground stations that you all kind of had to interact with. We at NASA have the Deep Space Network, and we provide that to our commercial and international partners for certain missions. So can you talk about the ground networks in your missions and thoughts, challenges, observations on the ground networks you had to all employ in different ways? So all of you, I think I'd be interested in that question. Yeah.
Well, one thing I would say is the truth of international cooperation is proven when you go to space, because you have to have ground stations around the world. And I can't tell you what a relief it was when you were waiting for acquisition of signal and you would hear Okinawa dish come on and say, I am Houston, I've got connectivity, or our dish in India that we were using. And so all around the world, it really does tie these missions together, because you feel that the team is humans around the planet working together. So I think there's a camaraderie, and it really it changes the way you look at things. I know I haven't had the fortune of going into space, but you hear about the transformative experience of going to space and seeing the world, hearing all the different accents and the different time zones and different music in the background sometimes when people from different dishes were supporting us. That ground network is essential. And we're going to need the DSN, we're going to need commercial dishes, we're going to need dishes from places, especially in the Southern Hemisphere. We don't have enough dishes in the Southern Hemisphere. So I really think that is an international effort that ties all of us together when we have to have reliable, continuous comms.
Other thoughts?
Yeah, we're located in an interesting longitude. There aren't that many antennae in the part of the globe that we are situated. So yeah, so we get the request quite often, and that makes us realize, as Tim said, that we are part of the global effort. And yeah, I hope we can maintain our antenna system so that we can live up to the expectation from our partners.
Vera?
We used Chandrayaan-3, our ground station at Bailalu. It's at Bangalore. That is a 34-meter antenna. Yeah. And also we have utilized from JPL 3 stations, Goldstone, Canberra, and Madrid, as well as from ESA 2 stations, Kuru and Gunili. With all that, also we have a visibility gap, I was telling, and these stations are very important, and we are also looking forward for another station which is coming up, geographically separated zone, so that we will have a good coverage. In addition to that, we also have IDRSS satellite which is coming up. That is a relay satellite which will be utilized for our Gaganyaan program, so that also will be used.
Yeah, Dan. Yeah.
I think I would just add that I'm excited for all the investments being made for more dishes and bigger dishes.
Can I ask the organizers to put back the slide of the real pictures of the lunar landers? I mean, our pictures are good, but I think I like that picture better. But yeah, with that, I'd like to thank the audience and everyone for this panel. I would say I'd like you all back next year for my panel, if they allow me, but I don't. I want a new crop of lunar lander countries and companies to be on this panel with me. However, in 2040, I do expect you to be back on the panel with me to talk about your visions and if they came to reality. So
deal.
All right, deal. All right, with that, let's thank our panelists. And I definitely want a picture with all of you and these real pictures. So thank you.
Oh, yeah, it's good, it's good. We'll retake this in a few years.